started. Restrooms are back out the door and down the hallway just a little bit. There's a cafeteria back out that way, also out down the hall where there's coffee, food, etc. For folks on the phone, we'll be advancing the slides as necessary. If you have questions, use the chat feature, and Holly will take care of you. So, also before I get started, I'd like to thank some people very much for helping me put this all together. I'd like to thank the Federal Technology Working Group and SLA Maryland chapter for co-sponsoring this event. I'd also like to thank some of the people who put a lot of work into making all of this happen. So thanks very much to Holly here at FedLink. She's done a lot of work. Really starting to get involved in. And I should say this is really getting involved in U.S. libraries because our colleagues in Europe and also in Australia and New Zealand have been at this in some cases for 5 to 10 years, really driven by some of their national research assessment exercises. So they've really done the pioneering work in this area. But in recent years, maybe over the last 2 or 3 years, I'm seeing more and more people providing bibliometric services in their libraries. I'm meeting people at conferences who are starting to get involved in it, either as part of their everyday activities, or in some cases, we're even starting to see, in fact, in assessment evaluations like myself and some others who are actually specializing in this kind of research. So I really think there's a lot of excitement around bibliometrics in libraries, and there's a lot of momentum in why people are getting involved in bibliometrics, particularly at this time. As I see it, there are really 2 major drivers for why this is kind of coming up in libraries. The first is external to libraries, actually. There's an increasing amount of interest from not only the federal government, but also from academic tenure promotion boards, from deans of academic libraries and so forth, who are really becoming more and more interested in using indicators like bibliometrics for research evaluation. I'm not going to talk about that in a whole lot of detail because our featured speaker just this morning, Duval, can talk a lot more about the federal push for R&D evaluation, but I'm going to talk about the driver that's really internal to librarianship, and that is the notion that librarians are facing increasing pressure to really justify their existence, to really prove to people that we actually matter and that we are valuable and relevant in this new information environment. And obviously this is something that's always happened. I mean, this is something that librarians have always had to do, but I think there's increasing pressure on us now and more pressure on us now than there ever has been. And I really think that's the case because there's been a fundamental shift in the way that people access and use information. So there's been a fundamental change in the primary problem or the primary barrier associated with information. It's gone from a problem of access to a problem of overload. So let me talk a little bit about what I mean by that. So in the past, really until about the mid-'80s, maybe early '90s, the primary problem for a patron who wanted to find information was getting access to that information. because information was stored in places that were very peculiar. You had to go to a specific place, you had to find the specific thing that you were looking for, and then you had to find the information in that thing. So it was a very multi-step process. So people weren't necessarily used to finding information in that kind of a context. So in that kind of an environment, then, a librarian's role is both necessary and obvious. Because people aren't used to going and looking for information, you need an intermediary. You need somebody to provide access to that information. So that sort of a mediator role is an obvious role for a librarian, and so the need for librarians was much more obvious. That has all changed. That is not at all the case. It's, in fact, turned around on its head. In today's information environment, with the advent of the internet, the World Wide Web, and particularly with the advent of Google search engines to make that content actually accessible, the primary problem with information is no longer about access. People have access. Now, I know that around 15% of the American population doesn't have internet access, but that's changing. The primary problem is not about access anymore. The primary problem associated with information is overload. We have too much information. There's so much information available, and there's so much information being created and generated on a daily basis. The problem is really finding this specific piece of information that is actually relevant to what you want. That, I think, is the primary problem we're facing these days. And in that particular kind of an environment, the role of the librarian is no longer obvious, because the librarian in the old role of mediating access is no longer necessary. We have access to information. That doesn't mean we can find the information, obviously, but we have access. So the primary role, I think, for librarians in this new environment is helping people deal with that information overload and helping people control information. So it's shifting in our role from, again, mediator to a controller or a manager of information. So a lot of the trends that you see in librarianship these days are related to this idea of helping people manage information. So the informationist model or the embedded librarian model is all about helping people with their very specific needs at the point of need, at the time where they need them. Once again, it's filtering information, controlling information. A lot of people are now working in knowledge management, web design. It's the same kind of thing. A lot of people are helping manage and control the information that's being produced. The same is true with data management. Once again, it's taking the data that is being produced on a daily basis, managing it, controlling it, making it available to people. So again, it's this idea of moving to this information control that I think is really what librarians need to be doing. So from that perspective then, bibliometrics is just another aspect of that information management, information control type of a situation, because it's helping people understand the massive fire hose of publications that are coming out on a daily basis. There are millions of articles being published every single year, and nobody can read them all. Nobody can evaluate them all. Even if you're doing an evaluation of an individual, sometimes that individual has several hundred papers. Well, you're not going to be able to read all of those papers for evaluation if you're looking for other methods. Or if you're evaluating a laboratory or an institution or something like the National Institutes of Health, which spends $32 billion every year, that's a lot of publications to try and deal with. So this turn to analytics is really just another aspect of this sort of information management, information control, and sort of mediating access to information in this new information environment. So that's what I think is sort of the internal driver for why librarians are getting into this. But to talk a little bit more about the external drivers and a little bit more about the renewed push from external stakeholders for evaluation, I'm happy to introduce Bill Duval. He's going to talk a lot more about the fact that people are asking for this kind of information, and they're asking the library for it. it's not just that we're sort of making this up. People are actually asking for this information. So to talk a little bit more about the federal push to evaluate R&D assessments, I'd like to turn it over to Bill Duval, who is the program manager for the Bibliometrics program at NIH. So, Bill?
So thank you for the introduction. I'd also like to thank Chris and his team for pulling this together. It's evidenced by the attendance here in the room and online that there is a tremendous amount of excitement around this activity. And as Chris mentioned, my role is not as a librarian. I'm actually in the planning, analysis, and evaluation shop at NIH. So we do a tremendous amount of this activity. We work with librarians. We work with a broad range of folks in different areas to really tackle this issue. It takes a diverse portfolio of folks to be able to bring their unique perspectives in library science research. So there we go. So I'll start with a quote straight up from the president. Really, I don't care whether the ideas are Democrat or Republican. I care that they work. And probably what you wouldn't have seen in the past is that last line. I do care that they are subject to evaluation. I'm going to talk a little bit about how R&D assessment fits in the overall picture, but this isn't just an R&D problem. From every program that we start, whether it's science, whether it's non-science, there is evaluation baked in from the beginning to be able to say, does this program work? How do we evaluate whether it works? There's a zillion metrics out there. What is the appropriate one for this particular area, whether at NIH or at HHS, whether it's teen pregnancy or Head Start? How do we start evaluating those programs from the get-go so that when that comes down the line, we can ultimately say, was this worth the money? Was this worth our time? And this is really baked into a number of different documents throughout the kind of evaluation world, and you'll see this paraphrased in a number of different reports. The administration is committed to a broad-based set of activities to integrate evidence, evaluation, in a wide variety of areas. Again, this isn't just research assessment. This is budget, management, operations. Ultimately, these want to be able to inform policy decisions. We want to be able to link up these data, these metrics appropriate for the particular area that we're looking at, and get it to policymakers to allow them to be better informed about that. So we don't operate alone. Bibliometrics is a trans-federal agency program. We don't operate in isolation. As I said, it takes a large number of people with a diverse set of ideas and approaches to be able to tackle these issues. So there's federal agencies, there's research institutions. We work with a large number of research institutions that are very, very interested in figuring out their own research portfolio, their own expenditures to be able to say, what's the impact beyond my community, beyond that faculty that has been supported? What's the impact to the local community? And then how do we communicate that? We work very heavily with the social science community. The NSF has a great science and science policy community, which brings together labor economists, social scientists, librarians, and brings them together with federal staff to be able to ask those tough questions and say, what data do we have? How can we slice and dice that data to be able to begin to tackle this problem? Obviously, because we're here inside the Beltway, we deal very regularly with the legislative bodies and the elected officials, both at a federal level and a local level. We interact with a number of different state and local government officials who are very interested, again, in how does this impact my community? How can we evaluate the broader research that is happening in our community? And then the taxpaying public. The administration has made openness and transparency a huge push, getting the data out there, as Chris said, drinking from the fire hose and trying to be able to make sense of that data in useful ways. And we all interact in this place. Federal agencies are very interested in portfolio analysis and that research evaluation, but ultimately, taxpaying public, congressional officials, they're interested in that economic impact, that return on investment. So how do we communicate that? NIH's role, for instance, is not necessarily to do research. Our mandate is to improve public health. We do that through research, but how do we make that connection? That research actually is improving public health. It seems like an obvious connection, but I think to some folks it is maybe not the most obvious. We constantly get those requests. How is X grant on fill in the blank buzzword at the moment? How is that improving the nation's health? And it's important to have groups like this one be able to take a look at those grants, evaluate them to be able to shape that message. So as I mentioned, there's many players. I'm here from the federal perspective, and I can tell you there's a large number of different bodies at the federal level who are interested in this. United States Congress, obviously. The GAO, which conducts, I don't even know, I have somewhere upwards of 20 to 22 inquiries that they're conducting at NIH that I'm involved in right now. So they're very heavily involved in analyzing how we do business. Is that worthwhile? How are we connecting up that research to make sure that it's improving public health on down the line? We have the Office of the Inspector General, which performs a similar function. The NSF Science and Science Policy community, as I mentioned. We have agency senior leadership. Every time a new piece of data comes out, we immediately get a call. What is going on here? What does this look like in the broader portfolio? How does this relate? Is there a gap here that we need to look at? Is this overfunding? Is this duplicative science? So we're constantly being asked whether it's something that hits the front page of the Washington Post or it's an internal analysis that we've done to be able to evaluate that and put it in a broader context. And that's really where the STAR Metrics program fits in very well. So as I mentioned, openness and transparency has really been the first step for the federal government, making the data available. I'll show in a little while, but for many of the federal agencies, even to this day, much of this information has not been previously publicly available, and that's one of the efforts that we're doing. So there's two memorandums here. There's also a congressional directive that agencies should put information out there in an open format in ways that folks on their own can utilize this information. They can download it, they can search it, they can analyze it, slice and dice it however they would like, and that we should proactively be using modern technology. We shouldn't be dragged kicking and screaming into the next century. We should be at the forefront of that to make sure that we are reaching, as Chris said, not just the people with internet access, but we're reaching the entire nation to be able to get that message across about how we're evaluating research. More recently, there's the Digital Accountability and Transparency Act, Data Act, which one of the things that it's promoting is standardizing those data elements across federal agencies so that when users come to this data, they can say a grant is a grant, a contract is a contract, a fiscal year is a fiscal year. But you would be amazed at the variation in that, for instance. Apparently calendars are not the same everywhere. So I won't speak to all of these. These are GAO inquiries. Each one of these, if you're not familiar with the GAO, each one of these can take up to 2 years. And I have 20-some going right now. And a lot of these are very heavily focused on what we're doing with the data. How are we evaluating that data? How are we linking it up ultimately with program management and policy making? How does this data, how does the evaluation better inform policy? And that's really the ultimate goal here, is to be able to take this data that we have, take that fire hose, run the appropriate evaluations, get those appropriate metrics for the science, and then make sure that leaders are informed. Whether they use it or not, that's their decision, but making that information available to them. So from an agency perspective, we've really been pushing in that third bullet, especially making the link between empirical data and policymakers. We've got to be able to link input. We've got to be able to link that input of we gave money to a specific institution, a specific person, link that with outputs and outcomes appropriate for the area of science. And NIH, we would say, how does that award ultimately translate to better public health? And that could take decades. For another area of science, USDA and agriculture, that metric would be totally different. But we've got to allow that flexibility to be able to choose the appropriate metrics and get that in the hands of the policymakers. And really that's all about that second bullet. How do we understand the impact that is appropriate for the area of science that we're reviewing? It could be scientific, it could be economic, as Congress is very interested in this. It could be a broader societal change. How do we stop people from smoking as much? How do we encourage people to choose healthier decisions, to make healthier decisions? So at NIH, we have a number of tools that we have worked with over the past 5 to 10 years. The NIH report tool really brings together a large number of metrics. It takes that awards data at NIH and connects it up with other databases so that folks, like many of you in this room, can slice and dice the data, can ask those questions, can link them up with databases that you are already using to effectively evaluate those awards and see what is that impact. So this is my boss, Dr. Sally Rocky. She's head of the Office of Extramural Research at NIH, and she has a very popular blog called Rock Talk, which is very new for us. It's been up for, I think, 3 years now, and it's really involved a culture shift in how we interact with the public, how we interact with researchers. It's a very, I would say, data-heavy. She's a data person. She loves seeing metrics. She loves seeing the evaluation results. These are some of the things that she has blogged about. One of the big issues for us is age of investigator. Our workforce is steadily aging. I think the average age in the early 80s, the average age when you got your first R01 was in your 30s, early 30s, 34-ish. Now it's 44, and it's climbing. How do we adjust it? How do we evaluate our workforce to make sure that our policies are moving forward in the way that we want them to move forward? There's a tremendous amount of work at NIH. I pulled a couple of NIH examples, but this work continues throughout the federal government, throughout research institutions, looking at citations, looking at patents, making those linkages across databases. On the left, you can see citations matched up with funding dollars for the NIH IC. NIH has 27 different institutes or centers who function in this space, many on a different disease area or topic. And so you can see the top right is NBIB. That's imaging, that's bioimaging. So there's a tremendous amount of technology push in that institute. So it makes sense that they have a large number of patents for funding. And then on the right, you can see a similar kind of comparison across federal agencies. And the data is just now starting to get to where it's of high enough quality to be able to do these analyses. And we need folks like in this room to be able to ask these questions, link up bibliometrics, link up patents across federal agencies, across areas of science, to be able to have this kind of information at our fingertips. So STAR Metrics, where we said we are a trans-federal agency program that is trying to look at the federal science investment, trying to look at inputs, link them up with outputs and outcomes. The White House Office of Science and Technology Policy, NIH, NSF, USDA, and EPA are all funders. They're all founding members of the STAR Metrics Consortium. One of the things that we've really been tackling over the last few years and only recently launched with Federal Reporter is this issue of data across federal agencies and across areas of science. As I said, ultimately we want to have the appropriate metrics for the area of science, but initially each data set is constructed so differently because it's appropriate for that area of science. So how do we bring all of these different databases together to talk to one another in a common format? So when a librarian comes to analyze this data, they know that it's consistent, not just at NIH or the HHS agencies, but across all of them, across these different areas of science, so that I know when I pick up a USDA award and I link it to a paper and a patent on down the line, that's the same as doing it for an NIH award. It's the same for doing it for all of the awards. So that data quality is baked in that we're doing those throughout the life cycle. So our initial focus has been on a small set of core data elements. As you can imagine, every federal agency does things dramatically different way. I was stunned to hear that people don't interpret fiscal year the same way, even though there's a definition online, check it out. Agencies don't do that. So you can imagine when we get to things like, what do you consider a contract? What do you consider fully funded? How do you fund these things? There's a tremendous amount of variation. NIH funds things in one-year increments. Every year you get a new award from us for that year's money. NSF does a few years. The DoD, for instance, fully funds. So they may do a 5-year award in one bulk payment. So if you were to compare, say, an NIH award in that same year, you would see, say, $100,000, and then you would see $500,000 for a DoD award. How do we make those linkages and make that understandable to folks who are using our tools? And really, ultimately, what we want to inform is we want to be able to allow for that portfolio analysis. We want to be able to inform policymakers. We want to be able to inform researchers who are tackling these tough questions, who are looking at metrics development, looking at benchmarking, looking at agency portfolios throughout the government. And again, I can't hit on enough linking inputs and outputs now. We've got to be able to show awards data. How does that funding hit? What does that ultimately mean on down the line? Whether it's economic, whether it's we helped fewer people smoke this year, how does that translate? How can we make that link? So I'll give you a second to digest the alphabet soup, which is that. So I won't go into it. Suffice it to say that it represents a very, very broad portfolio of areas of science. It represents a huge, huge chunk of the federal science investment portfolio. The big players, obviously, NIH, NSF, NASA, EPA, USDA. We have a number of different components. We have 3 more being loaded up at the moment on staging. We're actively talking with a large number of other agencies who are interested in, if they haven't put this data out there previously, getting it out there for the first time and kind of going through the growing pains of what that looks like. Or if they have it on their own website, if they have it on a much less visible place, being able to put it in one place, compare apples to apples across the entire federal spectrum. So just to give you kind of a brief demo of what the tool looks like and how we hope that it will help you as you continue working with this data. There are a number of different fields. What we have essentially done, if you're familiar with the NIH Reporter tool, we have stripped down, again, those common set of data elements across federal agencies. We've put it in a database and put together a pretty simple, frankly, considering the challenge involved on the back end, but a relatively simple search query for folks to be able to utilize. You can search on things like PI, Principal Investigator, and you can do text searches. So if you're interested in diabetes, you can pull that up. You can search across agency. You can search location, geographic. I'll point out congressional districts, again, inside the Beltway. It's a heavy amount of use. You could also look by, date. You can also pull down dates. You can pull down information on when things were funded, so you can see over time. You can see with diabetes funded more in 13 versus 14. And all of this you can export. That's been one of our heavy requests from the beginning was, your search feature is great, but how do I take this? How do I ingest the data in a usable format so that I can slice and dice it on my own? How I can take it, pair it up with my research institution's data, and be able to look at it at a more fine-tuned level. So that's one of the things we've been pushing. Again, there's the alphabet soup of agencies. I did just a quick demo search of child nutrition the other day to give you an idea of what that might look like. It pulled up a hit list, 5,358 projects in child nutrition across federal agencies, across years. So this is a pretty big list. This is a good swath of the federal portfolio. We have, I think, almost 800,000 records in total in Federal Reporter at the moment, and that's growing every month. So what you can see here is a kind of a hit list of the awards that have pulled up. There's a hyperlink to the award number and the title, and click on that. What that does is, and this is honestly for me, it's kind of a data geek and a science geek, this is the tremendously exciting part, the scientific information. In other places, there are reporting tools like USAspending.gov. There are other tools out there, but what Federal Reporter is very focused on, and it does that others do not, is it brings together that science information. We're not focused on vendor expenditures. We're not necessarily focused on the economic impact of sub-awards, for instance, like USA Spending. We very much want to link up that scientific information in the abstract, in the project terms, so that we can effectively evaluate not just NIH, but across areas of science. You can go over to the details page. This is for some of the more USA Spending type bents. You can see things like organization name, funding information, co-PI, which is something that is a new feature for many agencies. NIH has really only been doing it for the last few years since the policy change, maybe early decade. But many agencies are just now starting to come on board with this. And when you're doing things like network analysis, clusters, text mining, it's important to be able to get those linkages so it's not just one person, so that you can see that these networks span across institutions. One of the neat things for us that we've done is we've linked up awards with results. We've linked up with patents and publications for the NIH and HHS agencies. And you can see here, this is a UO1, so that's a cooperative agreement, many times for a clinical trial, for instance. And you can see over on the right side of the screen, it links up to PubMed Central. Links up there, you can see similar publications. You can see who cited it by using these external databases, by making those linkages. We allow for the type of analyses that might not be elsewhere. Now, this isn't available for any of the other agencies that don't use our grants backend, but by 2016, agencies are required to have these type of databases to be able to link the publications as part of that open access and being more transparent. So as agencies add their capabilities, we will continue to add those linkages again so that you can see, not NIH, you can see across the federal portfolio. And then one of our really popular features is similar projects. You take any award in the database, essentially calculates the fingerprint, it matches against all the other fingerprints in the database. So this is not area of science specific. You don't need to calculate a set of terms. It's all text mining, it does it for you. You can see here, by calculating a match score, it'll pull up the top 100 projects most similar to the one that you pulled. And again, this is across federal agencies. One of the features that we've added with the NIH reporters is a tool called matchmaking, which allows you to, not just with a particular award, but any body of text. You can copy and paste a poster abstract. You could, if you have a CV and you want to see who else is working on this, you could pull your CV and put it in Matchmaker, and it will pull those list of awards most similar to that block of text. And we're actively working to institute that feature on Federal Reporter because of the interest in those broad domains of science. And we found that this has actually been a tremendous tool. We've heard back from researchers at institutions who maybe are very agency focused. I know the folks who work at NIH in my field, but I'm not familiar necessarily with the broader work being done in other agencies. So I think our #1 search is the vanity search. Hi, I'm John Doe. What do you have on me? It's a very popular request. And part of that is because folks look at their awards and they say, what are the most similar? Who else is doing work in this field across federal agencies? We have some visualizations that allow for users to be able to examine their data. This is not necessarily a quantitative analysis. It's more of a qualitative evaluation that allows you to dive into the research portfolio, examine where the gaps are we funding in the appropriate places in the appropriate ways. Here it's by organization. You can see UNC Chapel Hill has a tremendous amount of research in child nutrition. You can cite the agency, institute, department, fiscal year, organization, state, and again, congressional districts. I can't emphasize enough how much you've got here. And we have all these numbers. I'm sure you are all familiar. We get the website analytics, so we see who's searching on congressional districts, and it's very much inside the Beltway. One of the other neat features for exploring the portfolio is to be able to take your hit list, child nutrition or whatever. We have a circles visualization which essentially through text mining pulls together this visualization and pulls together the 5 most common terms out of your particular hit list. And I chose diabetes to kind of drill down a little bit so you can see. Once you select diabetes, it then pulls up that hit list on the right. So within that subset of child nutrition, what mentions diabetes? And you can drill down kind of ad nauseum until the sample sizes are too small, but you can actually explore the portfolio in a visual way beyond just looking at a list of grants. Be able to say, again, are we funding enough diabetes research? Are we funding enough on metabolic syndrome to examine how that affects child nutrition and child growth? One of the neat features we've been able to link up lately is the basic math visualization. You can see the funding levels. You can see how awards are scattered across the nation. And I think it's important for us, kind of that communication messaging piece, to be able to say, you know, we fund $31, $32 billion. 83, 84% of that money does not stay in Bethesda. It goes out across the nation. That's a tremendous amount of money, and I think when people think about NIH, for instance, they think of Bethesda and they think $31 billion is, I don't know, Fort Knox style sitting there. But really, we work very heavily with research institutions. We want that money out there in the hands of the researchers, in the hands of the experts to be able to ask these tough questions. And ultimately, that's where we come in. We've got to be able to evaluate that. We've got to be able to show that. One of the really key things for us as we move forward is documentation. Because everybody apparently has a different definition of fiscal year and awards and things like that, we've got to be able to tell the user, if we can't present it apples to apples, we've got to be able to tell the user that it's not apples to apples. So when folks in this room go to Federal Reporter and they search for DoD awards, whatever, and they see once every 5 years that spike, that we have the documentation to be able to support that so that they know what those differences are across agencies. And they know the reasoning for that. There are very, very good reasons why there are quirks for particular areas of science. And it's up to us to be able to explain that to the user, be able to explain that whether it's research scientists, whether it's Congress, the public, whether it's federal staff internally, we've got to have the documentation to support that. So downstream, we have very ambitious goals, I will admit. We want to link up publications, patents. I'm sure many of you in this room are aware of the difficulties associated with the USPTO database. It is not a clean database. They do not, one of my, pet peeves, sorry if you're from the patent office, by the way. I love your database. It's just not as clean as I would like. But you are not required to have a unique identifier in the patent office. So John Doe, who submits in 1 year, may be the same as John Doe who submits a patent 6 months later, on down the line. And being able to get at that PI disambiguation issue, be able to say John Doe A is the same or different than John Doe B, is incredibly important as we tackle these issues about what are the networks, what's a research network look like in diabetes, how do we tackle that issue? So that's one of the things many folks in the research community, the social science community, using Google tools to disambiguate folks with a fairly high degree of accuracy and precision are really approaching this issue and hope to be able to incorporate that. One of the big things for us, I think, is expanding data set elements. We'd love to hear from folks in this room, what are useful data elements for you as you're tackling the problems that you face every day? What are things that we can ask for agencies to get in a low-cost, kind of not labor-intensive way for them that actually add value in those evaluations on down the line? PI disambiguation, RPPR, which is a new reporting mechanism for federal awards across federal agencies. How do we incorporate the structured data elements in those, link them up to awards so, again, researchers have the added database data elements, they have the added tools to be able to look and slice and dice data differently. And then ultimately, database linkages. We are not the only database out there. We understand that. We want to be able to link so that you can see in a central location, so you can download in a central location all of the information that you need. Two of the things that we are particularly excited about involve topic modeling and cluster analysis, text finding. What I've done here using one of the tools, somebody at NIH actually ran this one. Each one of those dots is one of the 80,000 awards that NIH gives out, or excuse me, applications that NIH gives out every year. And what we've done is we haven't vetted any information. We let it cluster everything on its own, and then overlaying that, we put in the integrated review groups, the peer review groups, to be able to say, where are the applications going in our peer review system? Is this where we want them to go? Are they going in the appropriate place? Are they being funded in the same way? And then ultimately, once they get funded, do they have publications? Do they have patents further on down the line? So again, that award life cycle, seeing where they hit us, not necessarily even at awards, before award, pre-award, when they come in the door. How do we link that up? How do we visualize that throughout the life cycle? And we hope to be able to bring similar tools to federal reporting. One of the neat things we've been playing around more recently with in the last couple of years is text mining and cluster analysis. This is a subset. It's not very clean, so I ignore the labels. But this is USDA data on child nutrition. And so the broader portfolio is the entire picture, and then kind of the highlighted pink is where child nutrition falls out. And you can add, this is a tool that allows you to add those further on metrics, those outputs, publications, patents, clinical trials guidelines. I'm sure there are USDA-specific metrics, the FDA's Yellow Book. We can add those on so you can explore your portfolio. So you can say, these are where the gaps are. We're funding child nutrition. It seems like they're in the middle, but not at the peak. Should we be funding at the peak? So the federal government is very interested in trying to find ways to evaluate our R&D portfolio differently. So ultimately, our goal is to serve the platform a single kind of stop for researchers, for Congress if they so choose, for federal staff, for agency leadership. When they're interested in a topic, to come to the federal reporter and have it all there in one place. We want to be able to allow for the flexibility to accommodate many different metrics, many different linkages. I get asked all the time, and I hate saying it, but there is no silver bullet. There is no one metric that tells you whether an award is a good award or a bad award, whether we should have funded it or not. There's no one metric that says a program works or it doesn't. So we have to build in the flexibility to incorporate metrics, to incorporate the appropriate linkages for those areas of science. Again, NIH has vastly different needs than USDA or NSF or even this community. How do we allow for those linkages and those inputs and outputs? I'll close with a quote from one of the reports that looked at the evaluation efforts recently. Actually, this is a couple of years ago now. Called the program evaluation efforts over the last few years the most sweeping and potentially groundbreaking emphasis on rigorous program evaluation ever conducted by the federal government. That's what we're in the middle of right now as federal agencies. We are constantly asked to evaluate our portfolio. Do you have the data to evaluate it? If you don't, go get it. Figure out a way to make it happen. If you do, go at it. Figure out a way to evaluate this portfolio and to answer these tough questions that we haven't been able to answer before. So that's really one of the drivers for us is our agency leadership is very interested in knowing, are we funding what we need to be funding? Are we funding in an appropriate way to move the science forward to better improve public health? And I'll echo what I said at the beginning, that takes a broad group of folks. I think there's a ton of research out there that shows that diverse work teams work better than kind of monolithic teams. That's true in this case as well. We need input from labor economists, federal staff, research institutions, social scientists, and ultimately this group. We need to have that input to be able to better inform evaluation and to move us forward so that we are funding the best science. The NIH, we need your help to make sure that we are changing public health, that we're helping people smoke less, that we are curing cancer in a decade or whatever the mission is. We've got to do that through our evaluation. We've got to be able to see what works and what doesn't. So thank you very much.
any questions? Yeah, thank you.
Sure. Yes.
So I know that people are requiring publishing online. Started to do older research. I've worked with them today. We certainly have a lot of them.
Sure, and correct me if I'm wrong. The question was about historical records with publications and things like that. If we have any plans to go back and kind of retroactively add that. I think the short answer is maybe. I can tell you, I have, I'm relatively young, so with the NIH, I have only experienced on e-copies of applications. I have seen rooms where the paper applications are, and they scare me. There's a trade-off. We would love to have that historical information. Or I can speak to kind of NIH and Federal Reporter. For NIH, and I think for many agencies, there's a tremendous cost in being able to make those available. We have them in paper in many places or scanned PDFs. NIH spends a tremendous amount of money and effort and a number of years to be able to scan the application in PDF. Many agencies simply don't have the resources to be able to divert away from critical things that they're already doing, critical programs, especially in kind of tight budget times where we're continually getting chipped away at further and further. I think the hope long term is that we would make them available. Maybe they're not standardized, maybe they're not machine readable in a way that we would really like. I think for Federal Reporter, it's about making sure that agencies understand the difficulties involved, but understand that this is the point in time where we, as a federal agency, as a research institution, this is the point in time where we should move forward and say, okay, that's probably not the best way to do it. Let's put this in a format that's machine readable so that we can evaluate our programs. $31 billion is not enough money to read every single application and figure out whether it was worthwhile. Going back 50 years, it's simply not. So we've got to figure out better and new ways to re-engineer, to enhance our business processes, get at that issue. And so maybe we won't be able to have those historical records in certain agencies or in certain areas, but to be able to say that moving forward we will is a huge challenge, and I think that's where Federal Reporter comes in.
But the question I have is, I can imagine that you show information about how many particular investigators and agencies and how often those patents are cited by other patents. But I'm wondering, is there other information that you show that might show economic impact?
We don't at the moment because of, again, we're only showing patents for the HHS kind of family of databases, family of agencies that use our grant and database. Let me repeat the question, I apologize. The question was since we show patent information for some of the awards, if we show linkages to economic impact. So with the HHS NIH awards, we show patents, but in a kind of very limited way. We show links to the actual patent application. We don't, because of kind of the messiness of the database and the tremendous scope of the project, the number of researchers we have, the number of awards we haven't tackled moving kind of beyond the patents in a broad scale. We have a few pilots that we're looking at to be able to say, how do we make linkages beyond patents? How do we show innovation? How do we show economic impact further on down the line? But again, those are, I think, in the pilot stages. Once you move on further to kind of the two-stage of HHS and NIH, see if it works there because we own, we control how the data looks, how we collect it, see if it works there, and then move to the billion other systems we interact with the federal government.
What are you thinking about regarding intramural, all extramural grant funding?
So the question is, what about intramural funding? Which is a great question. It depends on the agency. Some agencies up here show intramural funding because a bulk of their research awards are intramural funded. Some don't show intramural awards because they don't have an intramural program. So we've very much, again, to get to that flexibility issue, we've left it up to each individual agency to say it's appropriate for us to include intramural awards or it's not. So we've tried to, again, bake in that flexibility so that agencies are able to present and then document their data in an effective fashion.
So, part of the screen that you showed that has the science abstract description, if there were categories or topic areas, where does that come from? Is that the CI submitted, or is it?
The project terms? So the question was how are the project terms created on the details page for an award. So there's kind of two ways to do it. For NIH awards, I'll say this probably for all of them. For NIH awards, we have a system in place, uses mesh terms, things like that, to pull together project terms. Obviously, that doesn't work for kind of the broad portfolio. I'll share one little anecdote. When the DoD joined, we found a weird thing where grants were being coded inappropriately because they had blast. And NIH, we think that's a blast. So the DoD thinks it's something very different, very, very different. And so it was just throwing our numbers way off, and it took us a while to figure out how that was. And so what we've done since is we've switched to a more area of science neutral text mining creation where it looks at the abstract and it looks at the title and it will pull the key terms from those. So it's very domain of science neutral. It's not necessarily NIH focused. We would love to, again, if we had enough money, we would love to have almost a federal government and domain of science thesaurus that we could pull from to be able to create that. And we would love to be able to integrate that so that we don't have blast, cell, and IED in the same search pull. But yeah, right now they're pulled together in kind of a text mining fashion that's domain neutral.
You mentioned the data science, data testing, and related to your question. So we're trying to look at who's studying us, second, third, and then 22nd. 100 and then that economic impact. So can other agencies work with NIH or some of this?
Yeah, so the question was if other agencies can work on kind of the beta testing that we do internally, whether it's related to patents or economic impact. Absolutely. We have a very robust planning and evaluation community at NIH that runs a number of these different pilots and analyses. So we're happy to partner with whoever would be interested. I know that through Federal Reporter, I've come in contact with a large number of staff at other agencies who are doing similar work for their own domain of science, and I can put you in touch with those folks as well. I'm happy to link up with folks and walk you through some of the analyses that we are doing internally to tackle this issue. Little editorial, Eddie's editorial, I mean, we're all in this together. There is no silver bullet. I'm sure all of you get asked, what's the metric we should use? Is this happening? Is it citation? It's all of them. We can't look at one and expect that to be with this $1 million for an award appropriate. So we're happy to link up with folks. Okay, thank you very much.
All right, so now we're going to move on to sort of the heart of the program, where we're going to hear from a large number of librarians and information professionals at a variety of institutions who are actually starting to do this kind of thing and provide bibliometric services to their patrons. So up first, we have Stacy Bruss and Amanda Malanowski from the National Institute of Standards and Technology.
Good morning, everyone. we'd like to take this opportunity to thank everyone who put this together, and Chris, everyone from the Maryland Special Libraries Association, and Ya-Ling. We're happy to be able to speak with you today. My name is Malanowski, and over there in the red is Stacy Bruss. We are lab liaisons at the National Institute of Standards and Technology, or what we lovingly refer to as NIST. So what is NIST? We are the typical federal agency doing great science and technology research. Our output is roughly 1,300 papers per year, which we assess through traditional bibliometrics. But we also have a large realm of other things that our scientists are producing that are non-publication oriented, which include software and databases and a lot more. So our bibliometrics program focuses at 3 different levels. We have the library level, the lab level, and the institution level. And we'll address each of these in our presentation today. So our institution level, or our NIST level, is really focusing on the business of NIST. Are we achieving our mission, and are we achieving an impact in the world of science and technology and industry? So this process started a long time ago, and in the earliest part of the program, we were just providing a simple number of how many publications NIST puts out every year. Well, we've grown a lot since then, and these are some of our growth from there. So we started with that question of quantity, and then we kind of grew to, what's the quality of those publications? How do we know we're publishing good papers in good journals? So the library had to come up with a methodology for how do we consistently assess and fairly assess whether or not we're in a good journal. So for this, we used Thomson Reuters Journal Impact Factor. And we had to look at each category individually and take the top 10% of each of those and aggregate them into a big list of our top-tier journals and compare that to our publication list each year. And you can see we ended up kind of in the 30% mark for every year. And this was widely popular. That is the NIST Balance Scorecard, and we're consistently asked for this every quarter. So after they asked us about the quality, we started asking different questions. What's the breadth of our collaborations? Who are we working with? And how far does our reach go? So we looked at this at a variety of levels. We looked at the unique co-authors that were non-NIST. We looked at the institutions that we were collaborating with. And then finally, the countries, just so we could create a map of our impact and our reach. So this is what we have here. This we're asked for by management every year. So then we got really brave. We said we studied the external, and then we started asking our own questions. So why can't we do that? So we said, okay, we know about external, but what's happening inside? We have this big question mark. So a group of people decided, let's look at this, and we took a data set that wasn't very clean, all the papers and presentations and posters that went through that editorial review process, and we cleaned it up and tried to disambiguate the authors and see what we're doing internally and whether there's silos or whether there's key collaborators, and it helps us decide as librarians how can we best help as we're going through this process. So this is a work in progress and the first iteration, and hopefully it'll inform lab and NIST management of how NIST works as a whole. So then we look at the lab level, or the individuals within the lab. And these are some of the various bibliometric analyses that we do. Some of them are pretty standard, like the standard H-index reports for promotion packages, but we do have more. One thing that we did that was interesting is we turned it around. Instead of looking at the impact of an individual and their publication, we looked at the impact of a very specific publication. In this case, it was a publication that had been published about 7 years before the date of the study, so we had a good amount of citation history to look at. But we didn't just look at scholarly citations. This was a grayback report, or what we call gray literature because it was one of our technical series reports. So we wanted to also look at what other gray literature was citing. We also looked at full text downloads because a lot of the impact that NIST has, especially with my engineering lab, is straight to practitioners and skips the research part altogether. So you have to take that into account. And then for something new, we looked at the news, trade literature, and blog literature because we wanted to see how people were talking about the report. And what was very interesting is in this chart, you see that the publication was 2004, but it actually had been referenced in 2001 and 2003 as anticipation for the report before it even came out. And then it took about 4 years for it to really hit its stride in affecting policies and codes within the community. We also do something to proactively increase impact for our customers, where we analyze venues for them to publish their papers in. We do this at many different levels. It could be somebody already has a paper written, and they give it to us and say, help me figure out where I should publish this. Or we sometimes do it at a program or a division level to say, these are the best places for your division as a whole. And as you can see, we look at many different types of publications, from journals to conference to even trade publications, so that they can have that maximal impact. We go beyond just the impact factor. We look at the number of related articles because, you know, if people don't typically go to that publication for something on robotics, why would you publish a robotics article in there? But we also look at the subject category ratings because, you know, they are going to have many different subject categories sometimes that fall under that research. And then we're starting to use things like the eigenfactor, which are supposed to be more subject category neutral. And this is one of our more recent activities that we've been doing. We've been looking at research areas as a whole, and it helps the customers understand their research area and how their research fits into that field, or the world where are there research opportunities in that field. And as you can see, we look at many different types of factors, from authors to trends over time. And this particular network diagram was specifically for manufacturing robotics, and it looked at institutions and how different types of institutions were working with each other and how frequently they were working with each other. In this case, not frequently at all. And thirdly, we look at from the library level. We feel pretty confident in the way that we use bibliometrics to inform ourselves and inform management of our impact and also to help us make the best impact of our collection dollars. We have 3 different studies: an annual impact of our journal collection study, a biannual evidence-based collection development study that we do, and an upcoming archive journal holdings assessment where we're going to look at our 2/3 of our collection is archive journals. And so we need to figure out, because we want to do other things with that space, we need to figure out which ones we need to keep, which ones we can read, which ones need to be made electronic because they're actually being used by our scientists. And it's surprising. In our last study, we found about 25% of citations from last year's papers were from what we would consider archive journals. So for our evidence-based collection development, we don't just look at cost per download because that just says one thing, you know, that's one little aspect of piece of a collection. So we actually use Web of Science bibliometrics data to find out where our NIST scientists have published in the last 5 years and what publication venues they've cited in the last 5 years. So that's actually saying not only was it a download, but it resulted in a citation in their research publication. And we categorize and prioritize these journals, which allows us to have immediate flexibility should our funding change. You know, if we get a couple more dollars, we can hope, or more often than not, the journals were more expensive than they were supposed to be, and we have to cut a little bit more. But it also helps us in our communications with the customers, because customers never like to see a journal title go away. But if it has to go away, we can show them, instead you're getting this journal title, which will have that much more impact. So at the NIST library, we kind of think we have a lot of best practices, and we've been working through this process for a long time. So we formalized report structures and the review process to make everything more consistent and more accurate and more professional and so on. The best part is working on a big team that collaborates. We have a team that's so diverse. I mean, from librarians to analysts to metadata specialists, publication specialists. We have this great pool of resources to pull from when we get a request that we've never done before, or we want to do something that we've never done before. So we can really work together, whether it's brainstorming or pulling people into that project, we all work together. And at the same time, when we're done or when we're in the middle, we can speak to them again and share what we've learned so that the knowledge goes around the whole staff and everyone can benefit from a new innovative process or project. So we meet every other week to share those ideas and thoughts and our progress. So we talked a lot about the projects that we do, and we pull data from a lot of different sources. But some of our key ones are Web of Science and Google Scholar. Those are just the ones we use most often. And the family of Web of Science, journal citation reports and insights as well. But once you get all of those data sources and all the data, you need a little bit of a proficiency in Excel and Access to get the process started. And we're really finding a great need for open refine, which we've been using to clean up that data that doesn't always start out looking really pretty and doesn't want to do what you want it to do. So we're delving into that now and using that on a lot more projects. Once you have the data and it's clean, you have to show it to your customers in a way that they understand, in a way that makes it look important, and really highlight the key findings which you prepared for them. So a long time ago when I came on board, it was Excel for everything, bar charts and pie charts and all the usual things. Lots of pie charts. But we've grown since then, and we've gotten new programs. We worked towards the next step when we had the collaborations project, and I wanted to make a map, and I knew I wanted to make a map, and I wasn't sure how. So we researched and came up with Tableau, and it opened up a new world of visualizations that we could share with our staff. And then we got there, and we saw network visualizations and said, why can't we do that? And moved on to Sci-Squared, which is a great processing tool that takes out Web of Science or really a lot of different tools and convert it almost instantly in a couple of clicks to an co-author network or a bibliographic coupling network. And once you got that, well then you want to make it a little bit prettier. So you imported in a Getty and you add dimension and you add color and you add size. And it starts to take on a life of its own. And when the scientists and our customers see it, they get excited. They want more. They want to hear more. They want to be a part of our program and ask us for 10 more things that we didn't know we were going to do. So, with that, I'll open it up to questions.
Expand what exactly is Sci-Squared and how people might want to learn Sci-Squared from that?
The question was about Sci-Squared and to expound on it a little bit more. Nancy and I are probably familiar with Sci-Squared. We took an information visualization used together and learned about it there. Sci-Squared, or the Science of Science tool, is a robust program for doing data visualization. It looks at time scales, and we use it mostly for network visualization, but you can import Web of Science files directly in there in a .isi file. And when you do that, it gives you a whole load of options. It automatically knows that it's Web of Science information. And it gives you a whole list, whole menu option about those. And you can click and say, I'd like to extract the bibliographic coupling network. I would like to extract the co-author network. And you have it right there. What would have taken a lot of coding and a lot of stress is narrowed down to a couple button clicks and making our job a lot easier. we were asked if we considered any other statistics program like STAR or SAS, and we did. We actually have a whole data visualization computer just for these types of programs. But the skill set that we had, we didn't have much experience in R. We're definitely working towards that. We just haven't gotten there yet, so it's the next step on our long journey though.
I don't know all that sounds like really great. I think you get wondering, finding what to get it decided. So maybe just these were quick, easy, to learn them, but you're still kind of looking into that.
Yeah, we're not done with the tools by any stretch of the imagination. We started with the ones that we could get our foot in the door first and really make an impact with them, and that was, the tools that you saw, the Tableau sites where, and those were the easiest to get started, but we're looking for more robust and more powerful tools every day, and so, the next time you hear from us, those might not be the tools we recommend, but those are the initial ones that we've been started with. Well, even Typeware does work with ours, so, you can build, and as Amanda said, we've been building, maybe slowly, maybe quickly sometimes, but we also, unfortunately, don't have a lot of time. We always feel like we're, as you said, we get 10 more requests every request we do, so sometimes we don't want to be best.
You mentioned the data visualization. What platform was that on?
No, that was different. I think it's the University of Indiana. Yeah, it's a free MOOC. It's from the corner. Yeah.
Then, for your use of Tableau, when you're presenting your findings, you develop a dashboard or a base or you show them.
We are, the question was, with Tableau, are we using dashboards or are we just putting it on the computer? And for now, we are using the computer and we are pushing more towards the dashboards because that's really the way we want to go. We want our customers to be able to interact with the data that we've collected in their own and see their own conclusions and come up to those on their own. So we're definitely pushing towards the dashboard, but right now we're at the kind of the screenshot of the visualization. That's definitely what we're working for.
Much of what you showed us today was around journal, information that you get from Are you getting any interest in exploring, looking at attention in a non-academic space?
Okay, so the question was, a lot that was represented was about scholarly literature, and have we been exploring, looking at, things like the news and all. Other than the report study that I showed, we've done a couple more like that on looking at specific reports impact in news and all. And we did do one analysis where we looked at like how many news articles mentioned myths compared to some of our peer institutions. But those have kind of been one-offs now. We haven't formalized them in our Bibliometrics program at this time.
I noticed you use Web of Science a lot. You ever use Scopus? Some of us, that's a more relevant database because we're so heavily involved in conference with it.
The question was, he dealt that we use Web of Science. Have we ever used Scopus? Well, we actually don't have a contract with Scopus. We had to make the big decision a little while ago. And since we've had Web of Science so long, it's one of those momentum things so that we can have consistent trend data over those many years. But Scopus should be able to be used for all the very same things that we're doing. And there's even a Scopus input for Typeware.
Also, the tools that you mentioned for visualization, are many of those open source type tools? Or they at cost? They
all have a free version. Tableau has a paid version and a free public version, and the rest are open source.
you have an online question. Have you used transactional data from your agency, like web analytics? And can you repeat the question, please?
The question was, have we used transactional data, I guess, with some of these tools?
Yes.
Yes, we have done projects that use transactional data. We've been playing with projects this these couple of weeks using Tableau and functional transactional data. And that's where we'd really like to get started with those types of data sources, because we can import it in and play with visualizations and see what we're finding and what questions we might be able to answer. And we look to use Tableau that interacts with Google Analytics, which is what our transactional web data is from. So we look forward to, when we have the professional version, being able to upload that data and see it in life. All right. So up next we have Pamela Tripp-Melby and George Diez from the National Library of Education.
So we're delighted to be here today, and Holly, I might want to make sure I moved that. Is that all right?
Yes.
I didn't.
You're fine.
Disconnect us or anything. We're delighted to be here today, and what we're going to talk, I'm going to just say a few words about the National Library of Education, and then I'm going to turn it over to George, who's one of our reference librarians. He's going to talk about the National Center for Education Statistics, which is the group that we did the work for, and how we both did a metric and all of the steps we did to develop the metric, and how it also interacted with a bibliography that the NCES has had for many years. And we'll talk a little bit about our results and takeaways. So the library is one of the 4 national libraries, and the others, probably obviously, are medicine, agriculture, and transportation. The library is legislatively mandated to exist as part of the legislation for the Institute of Education Sciences, which is the part of the Department of Education that we're a part of. The library, it was created as a national library in 1994, but it actually, the collection and a library as the various predecessors of the Department of Education have existed since the late 1800s, and parts of our collection are historical and go back to the early 1800s. But our most important asset is our staff, and we also have Karen White, who's our project manager here today, who is very much involved in the work that George is going to describe. We do a lot of outreach, and the focus of the library services is really, although we do serve the public, the focus is really our Department of Education staff to help them better do their job. And we do a lot of outreach to staff about our services, one of which is to demonstrate the use of ED, brand, data sets, and publications by researchers. And we've been doing a lot of work to try to let staff around the department know that this is work that we can do. And so a senior staff member of one of the centers at the Institute of Education Sciences, the Center for Education Statistics, learned that we could do this, and for some of the same reasons that Bill Duval described in terms of justification for programs, wanted us to undertake a metric. And George is now going to describe the process that we went about.
Thank you very much, Pamela. Demonstrating the use of U.S. Department of Education products is part of what we do at the National Library of Education. And a main source of department statistical products is the National Center for Education Statistics. The NCES is the main statistical arm of the department, and functions of the NCES have existed since 1867. The NCES is one of the 4 centers of the Institute for Education Sciences, the U.S. Department of Education's Research Division. The NCES is comprised of over 35 statistical surveys which focus on education topics, including education assessments, early childhood education, elementary secondary education, post-secondary education, and other topics. And these are the names of the NCES statistical surveys. The NCES bibliography is a searchable database of citations to journal articles which use NCES products. So the bibliography, to a certain degree and in a certain sense, demonstrates the use of NCES products. This is the bibliography's website with the colorful logos representing the various NCES surveys. Historically, the content of the bibliography has been contributed by multiple sources, and the process has not been systematic or comprehensive. In particular, the bibliography's coverage did not extend to all of the NCES surveys that you saw on the previous slide. So as part of our project, we at the library made an effort to systematically and comprehensively discover content for the NCES bibliography in a way that would be repeatable and comparable from year to year, because we plan on doing it next year and the year after that. The library's task then was to produce a metric for the NCES and to populate its bibliography. For the metric, the task was to find citations to scholarly research published during the fiscal year that used NCES products. The total number of citations would be the metric. For the bibliography, we would submit the citations we found as new content for the bibliography. The metric was used by senior NCES management to demonstrate the use of its survey data. So, step one, because we were going to be doing this each year, it was important for us to develop a good workflow and to document it. So step one of our project was to divide up the work. First, the staff got together to decide which of the library's bibliographic information resources to use. We settled on 4 bibliographic information resources: Scopus, Web of Science, Science Direct, and the EBSCO databases, which included Academic Search Premier, Social Sciences Full Text, and Education Source. Four librarians conducted the searches, and 2 managers conducted periodic quality control. For dividing up the work, we had to decide on 2 alternative strategies. The first alternative was to split up the surveys among the 4 librarians. So we had about 35 statistical surveys to work with, so that would come out to about 9 surveys each. So with this alternative, each librarian would would search the products of about 9 surveys using each of the library's bibliographic information resources. The second alternative we considered was for each librarian to stick with 1 bibliographic information resource and search all 35 surveys. We decided to go with this second alternative so that each librarian could hone a deeper expertise with one of the particular information resources, because each of those resources have their own specific features and functionality, and they have technical requirements for using them, such as how a search string is conducted. So we thought that would be a good idea. So you could say we had a Scopus expert, we had a Web of Science expert, a Science Direct expert, and an EBSCO expert, all searching all 35 surveys. And that's how we divided up the work. Step two was to schedule the work. We wanted to schedule the work out evenly over a 5-week period, enabling us to complete the work on time while continuing to keep the normal ongoing library function operating as usual. We only had 5 weeks to do the work because we had to wait until the end of the fiscal year to start, and that is for us September 30th. And we wanted to finish by the end of the calendar year, but we also wanted to leave time for quality control and to have time to address any unforeseen problems. Some surveys had a great many products to search, so those surveys were spread out evenly over a 5-week period. Other surveys had relatively few products to search, so we anticipated that those would be relatively easier to do. So to spread the work out evenly, each survey was ranked on a scale of 1 to 3 based upon its number of products. We used this ranking to construct a calendar of surveys scheduling the work. This is week 1 of the 5-week calendar of surveys, which we used for spreading out the work. The harder surveys were assigned a number 3, were spread out over 5 weeks, so that we only did 1 or 2 of those each week. Similarly, the easier surveys assigned number 1 were spread out, as were the in-betweeners that were assigned a number 2. We used this survey. We used the calendar of surveys to create Excel files containing the titles of each survey's products, which were the bases for our search strings. Each week, we would search for references to the titles of the products of the surveys scheduled for that week. Step 3 was basically about formatting the search results for the bibliography. For the metric, only a number was required, that number being the number of unique scholarly references to NCES products during fiscal year 2014. However, for the bibliography, the results had to be usable for the bibliography database. After some investigation and experimentation, we determined that the formatting of the records in the bibliography were very similar to the default comma-separated value export from RefWorks. So RefWorks was used as an intermediate step to put the results into the correct format for the NCES bibliography. One addition was that we added a field which identified the name of the survey. This is how we did that. We exported the search results from RefWorks to Excel, and we added the field data source and populated that field with the name of the survey to which the cited publication title belonged. This is because the NCES bibliography is searchable by survey name, so you can go to the bibliography's website and say, show me all the articles which cite the early childhood longitudinal study. So we added that metadata element for that purpose. This process made the search results usable for the NCES bibliography by formatting the results correctly, making the record searchable by survey name, which is what I understand. Step 4 was to formulate the searches. We derived the search terms from the titles of the survey products. We found the list of titles on the products and publications pages of each NCES survey. So each NCES survey has its own website or its own web page, and it has links to its publications. And so that's where we got the titles that we searched on for citing references. This step involved a great deal of collaboration, particularly in the early weeks, and we met often in order to discuss our processes and our results. For example, we worked with each other to develop optimal search strings, particularly for some of the more challenging titles. Some titles would tend to create false hits. For instance, there's a very popular NCES publication called the Condition of Education. So if you just search Condition of Education, you get a lot of false hits. So we met a lot and talked about the best way to avoid doing that and to make our searches as precise as possible. Similarly, we also discussed the need to search on popular names. Some of the surveys have popular names. For example, the National Assessment for Education Progress has the popular name, the nation's report card, so, which you've probably heard of. And we're probably familiar with how researchers do cite the data that they use, and sometimes they cite it in different ways, so it's important. So we decided it was important to do things like that. We also discussed whether it would be a good idea to combine our search strings into large clumps and thereby run fewer searches, or to break up the searches into their component parts. On the last point, we decided that it was better to break the searches up and conduct the searches title by title, rather than clumping them up into large, humongous search strings. Here you see the Excel file for week 1 with the open tab. You can see the tab circled at the bottom of the Excel page for the Early Childhood Longitudinal Study, ECLS, showing some of that survey's products, which were taken from the ECLS publications page. Each survey has its own tab, and each tab contained that survey's product title. And each week for 5 weeks, we worked off a spreadsheet similar to this one. So we formulated the search strings and ran the searches, organized the search results by survey, and used RefWorks as an intermediary step for formatting the search results correctly. The end result of that process was a deliverable for the bibliography, which was a listing of citations to scholarly research published during fiscal year 2014, citing NCES products, and all of it was organized by NCES survey. Now, because an individual article might cite more than one survey, for the purpose of the metric, what we did was we merged all the results that we gathered for the NCES bibliography, and we deduped them, and we got the metric number, because the metric number was for the number of unique citations. here's a summary of the number of citations we found for the bibliography and for the metric, and also a tally of the number of citations we found for some of the individual surveys. We found over 6,700 references to the surveys and their products, which went to the NCES bibliography. And for the metric, the number was 3,568. One thing we accomplished was to discover bibliography content for surveys that were not previously included in the bibliography. In particular, prior to our work, the bibliography, for example, had no content for the National Assessment for Education Progress, the nation's report card. And we found almost 600 articles referencing the nation's report card. And today you can use the NCES bibliography and find NAEP data as well. Takeaways, we learned that because of differences in content and functionality, the bibliographic resources we used complemented each other and each contributed to the results. As a result of the outreach we did to publicize the metric, we succeeded in growing this part of the library's business. And we have received additional requests to do cited reference searching. This was a large-scale, long-term project, so we worked through challenges together. We helped each other, and as a result, it was a terrific bonding and team-building experience. And for me personally, it was a wonderful opportunity to develop my skills managing a multifaceted project, working with a terrific group of talented people. And that's it. Thank you very much.
Question from online. They're asking, do you plan to expand into altmetrics, and if so, how?
So the question is, do you plan to expand into altmetrics?
And if so, how?
And if so, how?
So I think we first of all, we started with, when I negotiated the terms for this research project with the people at NCS who wanted it, the bibliography has always been about scholarly literature. So the idea was to populate the bibliography at the same time. And because I knew that there were so many products, that there were 35 surveys, but that each survey had multiple products underneath it, I was a little concerned the first year we did this of the scale of the project and the amount of staff that we had to do it. So we limited it to peer-reviewed literature. Now that we've got the process underway, I think we can consider other forms of citation of literature. We did do actually a little bit of work looking at news, because many of these surveys do end up in the news as well, and obviously social media. But I think it's a question of resources on our end in terms of our time and ability to do this. The purpose of the metric was for reporting purposes up through the department, and because we're the research arm of the department, they were primarily interested in the citations by the research literature. So that part came from the requesters for the work. I was just going to ask if education would be open to be working with library students or information management students who are looking for projects that they can do for academic credit. Not always being tagged by students who are looking for projects that they can do remotely, which I'm guessing they could in particular instance. And maybe they could help you find processes that you can work on.
And so the question is, would we be open to working with library school or information management school students on this project? And the answer is yes. We can talk after this.
Just one.
The question is what metrics we were pulling out of Science Direct, and I'm pretty sure the answer is citations to literature, but I'm going to let George answer that.
That's correct. The metrics were the same for all the information resources that we use, so it would be citations to NCES products of scholarly publications that were published during fiscal year 2014.
I have two questions. The first question is, I also have these records for deducing, and I was wondering, since you went out and wasn't sure if you were doing the deducing only in reference to doing it also on the spreadsheet. I was almost thinking, I find it so painful in RefWorks, maybe this would have been easier to do it using a different line in the spreadsheet. Or can you talk about your deducing process?
So the question is asked us to talk about our deducing process and where we actually did it, whether we did it in RefWorks or in Excel, and we didn't use any other tools other than that. So I'll let George answer the question because I don't know.
Yes, we used RefWorks for the purpose of formatting the results correctly to get the data fields in the correct order, but we deduped in Excel because it was faster. We sorted all the results by title and then deduped that way. It was very fast to do.
I imagine it would be much faster. The other half of my question is, it seems like this is very similar to what we do with instrument bibliography, telescope bibliography, and spacecraft bibliography. And I know that they're trying to develop some standards and best practices in astronomy libraries for doing these bibliographies. I was thinking maybe there could be a collaboration. Maybe it should be a more general idea of we could develop best practices for doing these. This is very similar to doing a spacecraft bibliography, actually.
So you are from?
I'm from APL, the Johns Hopkins University.
So the question is from the Johns Hopkins School of
Applied
Physics Laboratory, and she's noting that the kind of bibliography that we fed information to is very similar to bibliography they do in the astronomy field, and whether we be interested in talking about standards and developing systematic ways of doing this, and I think it's a great idea. One of the advantages of sharing these kinds of practices is that we get to talk to other people who are doing them. I mean, for us, it was really unknown territory. This was the first time we had done something, and we realized that it was going to be very big because there was a large, for us, with our resources, it was a very large project, and so it would be great to work with other people who have done this and have ideas of more systematic ways to do it. So the question is, in using Scopus, was it more limiting to use an abstracting and indexing database than a full text database? I'll just say, I think from my perspective as the manager of the project, I think one of the reasons they divided the work up by database was to get that kind of experience and depth with the particular sources. We also, I think, speaking to a question that was asked earlier about another presentation, we used both Scopus and Web of Science because we did find different results in them, and they were complementary. We didn't find any one source that gave us everything. That was one of our questions in the beginning was, did we really need to use all of these different sources? And the first time around, we figured it was one of the things we would learn, and we did, and it was really necessary to use them all. Scopus, we found, tended to be a little bit more skewed to the social sciences literature, which is obviously for use of education literature or surveys, heavy social science literature, heavy use of that. But I'll ask George, did you find differences between, say, using the EBSCO databases, the full text database, and the citations?
Yes, I think that's an interesting question because sometimes education researchers differ according to what they define as use. does a research article use their data? For Scopus, we search the cited reference fields, whereas for the EBSCO databases, we were able to search the abstracts and in some instances the full text. We took a more expansive definition of what use was. So if a survey popped up in the abstract or in the introductory discussion of the topic, we consider that as using the survey data, if nothing else, for context.
You generated any data sources or government plans available for anyone?
So the question is, did we produce any overlap data of the four sources? And is your question about whether we found some sources more useful than others, or?
How much was unique and how much was shared?
And I don't know what we did with that information. We were just so glad to finish.
Yes, we were very glad to finish. And that's an excellent suggestion. And no, we did not capture that and we did not analyze it. But yeah, that's a very interesting thing that we might think about doing next year.
But George, we did count the number of unique citations from each source.
Yes, we did.
So Karen's point was we actually counted the number of unique citations. I don't think we did very much of that information. Again, we kind of got to the end of it and moved on to the rest of our work. But I think one of the things is obviously we're looking forward this summer as a period when we will start planning for next year. And what we need to do is, the big takeaway for us was that we needed all four sources. We couldn't do, there was enough uniqueness that we definitely needed to do all four again. And within EBSCO, use several of those databases. Yes. Absolutely. Absolutely. Thank you.
All right, we're going to take a short break and come back here maybe 5 minutes after 11. Thanks. All right, I think we're going to start coming back to order. You can all take your seats and settle down a little bit. We'll get started here. Excuse me, everyone. We're going to get started sometime here very quickly. So I have a couple of announcements to make before we move on to the program. If you're calling into the presentation, please mute your phone. There's been quite a lot of comments about that, so please do mute your phone. The slides will all be available from the SLA Maryland webpage. So we can talk to Nancy Farget a little bit more about that, but the slides will be available. Let's see, the next event that SLA Maryland is going to be planning will be on November 5th. It's going to be about leveraging data to lead, so stay tuned for more information about that. So next, we are going to move on right along with our program, and we're pleased to welcome Jessica Hernandez from the Food and Drug Administration.
Good morning, everyone. Thank you for having me, and thank you, Chris, for organizing this really exciting workshop. So my talk is going to be a lot more conversational. A lot of our work in this area is evolving, and so really looking forward to hearing your feedback and questions. I also want to say please interrupt me at any time. I'm Jessica Hernandez. I work at the U.S. Food and Drug Administration. And I wanted to first start with just a little information about who we are and what we do, just for context. So I am head of the Innovation and Technology Solutions team in the Office of Science and Engineering Laboratories at the Center for Devices and Radiological Health. And so that's a really big mouthful. But I essentially run an innovation shop in the Office of Science and Engineering Laboratories, OSL. We are the research engine of our center. Our center regulates medical devices and radiation-emitting products. So a little background on how our group started. We are a new group. We really only officially sort of formalized in the last year or so, but the upsurge of digital information has really changed the nature of scientific mobilization. Knowledge is increasingly shared more openly and more broadly. And there's been a lot of advances, too, in research evaluation, and so unprecedented opportunities to really target and increase research impact. And we also, historically, prior to me coming on board 3.5 years ago, we had this challenge of having this very sort of unique research program, but not being able to tell our impact story very easily or very well. And I think in the current budget climate, that's increasingly important to do. So my group, ITS, is our office's response to the sort of next generation of R&D. And our vision is really to develop a first-class knowledge ecosystem within our office and within our center to really ensure that the U.S. is the world's leader in regulatory science. That is our center's mission, and we really try to align with that. So to that end, we design and implement our office's knowledge strategy to be able to build and maintain the sort of robust information infrastructure that you would find at any first-class research organization. So a little bit about our shop. We are a small but very hardworking and passionate team of library and information science professionals and also developers. So we work very closely with engineers and computer scientists who are really like the kindred spirits of librarians, and that's how we're able to maintain this broad portfolio. So our work in OSL really falls into these three buckets. The first one is information technology. So product development and deployment related to knowledge systems, learning technologies. We also do some business IT, knowledge services. So digital curation of our different knowledge systems, strategic intelligence, including horizon scanning, research analytics, which is I'm going to talk about today, expert discovery, and what I call C-suite information services, so just-in-time, high-level information services for our senior leadership, as well as systematic reviews. And then finally, project incubation. So we do a lot of consultation on different projects as well as collaboration, and some R&D experimentation in our own field of information science. So I want to talk today about bibliometrics or scientometrics through the sort of broader lens of research evaluation. We really see bibliometrics as one of the many techniques that can be used to better understand research and program performance. So I want to talk a little bit about our approach, which I really think is being holistic, integrated, and collaborative. So when I say holistic, I think we look at research impact through the whole elephant, so to speak. So looking at citation analysis in the context of broader researcher and organizational activities. Also looking at impacts throughout the entire research life cycle and not just downstream. Integrated in terms of, I use this tool, this term, research analytics, and I think to me that really kind of describes the whole sort of suite of business processes, products, services, and tools that support really robust research evaluation. And lastly, collaborative. A lot of our work really requires continuous input and collaboration with our stakeholders. So this work is not done in isolation. It's really done based on some sort of a driving business need and in collaboration with the stakeholders and the researchers that we serve. So let me start off by talking about our holistic framework. And this is an example of our working metrics framework at our center. And I was detailed to the office of our center director last spring to help kick this program off. And we realized that we had an opportunity to make a really strong case for funding, increasing research funding. We were up for negotiations of an act that allows us to cap medical device user fees. So essentially, sponsors pay our agency to review their new medical products, and we were the only center within our agency that wasn't receiving research funding through this act. And so we're talking about, tens of millions of dollars here. And so that was really an opportunity for us to be proactive and to implement this sort of broad and consistent research framework, research evaluation framework within our center, so that we could then be really well positioned to make a compelling argument for access to this research funding. So we started off with a pretty rigorous analysis of the current landscape. So what research activities are we involved in? What are the current measures? What are the current information systems that we have? What are the information resources that we have to be able to do this work? We also talked to a lot of stakeholders across the organization in all of the different offices, in the laboratories, the various divisions. So we really wanted to get input from this very sort of broad spectrum of people within the center as well as externally. We also engaged in pretty extensive research on the trends and best practices in this area, particularly with an eye towards what was being done well in the federal intramural research space. And so we talked to a lot of people. We talked to Bibliometrics, we talked to Chris at NIH, and that was really informative. We felt that we didn't have to reinvent the wheel, that, there's so much wonderful work being done in this area, a lot of great literature, and so we thought that it made sense for us to really take what's already being done and learn from other people's experiences. So we worked with Deloitte to explore two different use cases so that we could get a sense of what we were doing well and what we weren't doing so well, and how we could start measuring it. We thought that it was also really important to be able to baseline our efforts moving forward. So once we, began implementing this framework, how are we going to, let's look to what we've already done to help establish performance metrics for the future. So this logic model, which I know is really small and hard to see, but it represents at a very high level the different levels of impact and the related metrics throughout our research and regulatory pipeline. And there's really a special focus here on how our public health mission is advanced by more downstream impacts, like research imperatives. This here is a list of 65 metrics that we developed that came out of this project. We're right now at the stage of looking to see which one of these can we actually implement. So this is our big sort of wish list here. And you'll notice that publications is 1 out of 65, and it's ranked 61st. So that just shows, the sort of the diversity of the different research activities that we're involved in, as well as the need to look at research impact in the context of the broader organization and the organizational mission. So not engaging bibliometric analysis in isolation. So this is, in full disclosure, I completely ripped this model from a beautiful infographic that was developed by the University of Central Florida Library to describe their library services. I loved it, and that's why I used it. And this shows to me how impact evaluation and the related products and services fit into the sort of broader research lifecycle in our office. So from funding and planning to the very end, knowledge transfer, and then the beginning of the cycle again. And to me, it also illustrates how my team, Innovation and Technology Solutions, kind of fits into this broader ecosystem and how we work with these ancillary resources like research administrators, high-performance computing, as well as the researchers themselves. So this here is a snapshot of some of the products in our portfolio. And I wanted to share this because I feel that, having this sort of existing infrastructure really advances our capacity to engage in comprehensive research value measurements. It would be really difficult to do without that. And when I first came to OSL, I spent my first couple months hand searching for, throughout these different citation databases of all of our publications for an annual report. It took me months, and it was horrible. And so it became very clear that we needed to develop this infrastructure in order to engage in this kind of work more efficiently and more comprehensively. And so that's why we have, over the last 3.5 years, endeavored to build this infrastructure. So I can just tell you really quickly, the OSA repository is an institutional repository that we have of our research outputs. A lot of what we do is we link to library databases when we can, but a lot of our research outputs are not necessarily indexed in the databases that we have access to, and so in that case, we have to do a lot of our own curation. We also produce a wide variety of research outputs, not just publications, but also data sets, computational models, 3D models, images, software code, and so that's something that we all try to capture and track. ORCID is another really integral part of this. We are an ORCID early adopter. We batch create ORCID IDs for our researchers, and we manage their IDs on their behalf. We also have an expert discovery tool called Profiles Research Networking Software, and this is a tool for expertise mining. It also has built-in analytical capabilities, and so we're able to do social network analysis as well as more advanced bibliometrics through this tool, all using open source software here, except for this last one, which is the ISO database. It's built using the Salesforce.com platform, and what that is a research projects database that integrates our resources like project funding, scientific staff, space, facilities, laboratory equipment with our research projects, our different research and regulatory activities, as well as our outputs. And through this, we've endeavored to close the gap between our clearance, our manuscript clearance process and our final publications and other outputs. So in terms of our collaborative approach, I think that this is really critical. So we endeavor to work really closely with our different stakeholders across different levels of the organization. Market development is really an important part of this strategic plan, and so building these relationships with different stakeholders, undertaking a needs assessment, and also looking for growth opportunities. So what I want to do is share a few examples of our work in the last year or so, and this is work that has been undertaken by team members in my group as well as some of our collaborators. This is one really interesting use case, and this relates to mission impact. This was developed by Dr. Maria Murray, who is one of our collaborators in the Office of External Expertise and Partnerships. And what this is a citation analysis of pre-market submissions that reference a very important research area for us. So this is references to a project called the Virtual Family, and what this represents is our effort to integrate computational modeling in our regulatory submissions process to be able to reduce the need for human and animal studies, as well as to limit the time to market. And so what Maria did was that she mined our regulatory submissions database for these references to our research. And you'll see that it really represents the breadth of our research and how we have 42 different unique sponsors or medical device companies that have cited our research in their work, as well as 95 unique medical devices that have been impacted by our research. And this was a significant undertaking for her. We supported her work. But I think this to us represents a model for how we'd like to be able to do this bibliometric analysis moving forward. So not just looking at citations within the research literature, but beyond that to more midterm indicators of impact like regulatory submissions. Here's another use case that was developed by a team member in my group, Nicole Amelia, and this is an example of regulatory impact. So what Nicole did was that she looked at a research area that is pretty significant to our office, which is ultrasound. This is a retrospective study going 35 years back to look at the impact of our research as well as our regulatory work, so developing consensus standards and guidance in this area. And I think that, what's very interesting to this is to see, to be able to make this sort of connection between our bench research and our regulatory impact. And that's a really significant thing for us because, we're not we're not a big funding agency. We're not really a dedicated research institution. We are a small intramural research program in this broader regulatory agency, and so making the case for research is an ongoing challenge, and this is one approach that we have to be able to do that. Here's another use case, and looking at our external expertise and our collaborations. So the nature, the productivity and the impact of our external collaborations with different institutions and scholars. We also recently undertook a project looking at the impact of our technology transfer agreements. We have several collaborative research agreements with academia and industry, material transfer agreements, research collaboration agreements, and so looking at the impact that those different agreements and our knowledge transfer has had. Lastly, we did another bibliometric analysis of an NSF-funded Scholars in Residence program where we bring visiting scientists from all over the world to come and work in our office, and looking at the value of that program. Similarly, one thing that I'm interested in doing over the next year or so is being able to start looking at the impact of our STEM education investments. About half of our workforce are graduate students and postdoctoral fellows, and so being able to look at their work and make a connection between our own investments in STEM workforce development. So here's another use case, and this was a pilot that we undertook this year as part of the performance appraisal in our office, and so we generated these annual accomplishment reports for a subgroup of some of our researchers. And what this project was using our existing data from a variety of sources to automatically create these individual accomplishment reports for our scientists to really be able to represent the breadth of their research and regulatory activities. So everything from publications to presentations to academic appointments to training received, training given, awards, research funding, internal as well as external, really the whole gamut of their research activities. This was difficult to do. We hope that next year is easier. I think having that infrastructure is going to be really important for us to be able to do this easily and for everyone. But one thing that I want to note here is that we did do some basic citation analysis, but that was really only part of this. And another, I think, important piece of it is that we worked really closely with the scientists who participated in this pilot, and so we sought to be able to give them as much data as possible, but they did have to fill in some information. We're not capturing everything, and we also had them review it. And so it was a sort of iterative and collaborative process, but it was a way for our team to really be able to add value and to demonstrate, what types of things you can do with our institutional repository as well as some of our other products and services. So here's another interesting use case, and this is a project that I just started with our scientific computing laboratory. So these are guys that we work really closely with, and they're often doing things for us, and so I was really excited when I could finally do something for them. We have a supercomputing resource in our office, and I think what's interesting about this is that they have a very similar challenge libraries have. So it's a very costly resource, and they don't have a way of making this sort of, direct correlation between utilization of this resource and research impact. What we're starting off doing is just doing a citation analysis for 250 of their regular users, mining that data set and also trying to see references to our high-performance computing group, to our office, as well as to some of the software and the tools that they use that could indicate that it was utilized in the research. But I think that moving forward, what I've suggested to them is developing a sort of multi-pronged approach where we collect information from their users on the front end. So start minting ORCID IDs for them so that we can more easily track them, get preliminary information on what their anticipated research impact is, and getting them also used to reporting on a regular basis so that they see that as part of what they have to do to be able to receive this free service. And I think this is significant because this small group provides services for the entire agency, but also for other agencies within the Department of Health and Human Services. So lastly, and this is a little kind of different, but I think it's also interesting, and this is a science and technology forecasting project that we have. So one of our center's strategic priorities is being able to do a better job of scanning the horizon for emerging technology so that we could ensure that once these new medical products come through our doors, that we have the expertise to be able to quickly evaluate them for safety and effectiveness. So a lot of this is about science capital management and mobilization, but also ensuring that we're investing in the right research at the right time and also the right level of investment. And so I think that in order to do that, we really have to get a sense of what's coming up to the horizon. And so we started off using SAS Analytics, the SAS Analytics technology stack. We built a data repository of PubMed literature, Web of Science literature, and then data from public federal sources, SCIR, SCTR, patent data, as well as research funding from NIH, DOD, and NSF. And what we're doing now is that we're working with a program from CIARPA. It's an intelligence agency, and they have a program called FUSE that we're putting a research collaboration agreement in place with them so that we can use their software and their data to continue this project. But you know, we're very interested in being able to mine the scientific literature as well as other data sources to get a sense of how these new areas are evolving. So our use cases right now for this pilot are additive manufacturing, 3D printing, tissue engineering, nanotechnology. We're also looking at other topics like medical robotics. And what we've done is a lot of analysis and modeling of PubMed and Web of Science literature. So this is a project that you know, I think is evolving, and it'll be interesting to see how this turns out. So I'm probably running over for time, but I just wanted to quickly talk about some of our lessons learned. And I'd start off by saying that there is no silver bullet. Research assessment involves a lot of trade-offs. It's imperfect. Mixed methods, I think combining quantitative and qualitative measures is really critical, as well as multiple tools. And then you also have to address, or be willing to address some of the enduring challenges. I think for us too, you know, we've had to start a sort of cultural shift in terms of moving away from this more traditional academic model of research assessment to developing one that really fits who we are and what we do and what we're trying to get to. Also, you know, there is no one-size-fits-all approach. That research evaluation should really fit the broader sort of organizational context, as well as be representative of the breadth of research activities that you're undertaking. Also, first things first, that the goals of the assessment should really drive your approach to it and not the other way around. And that should drive, you know, the framework, the techniques, the information resources that you use. Also, that you need to be able to compare apples to apples. So this is particularly important for us because we are an intramural research organization in the federal space, and so we can't compare our research impact to that of an organization like the NIH because it just doesn't make sense. And so that's something that I think is really important to keep in mind, and we've worked really hard to try to find comparable organizations in government as well as externally so that we can make an appropriate assessment of our overall sort of organizational performance. I think we're all also very interested in being able to leverage the Bibliometrics program to do that. I'd like to be able to do a big data dump of our institutional repository where we also have impact story metadata. That was something I should have mentioned. And you know, open that up so that we can hopefully start comparing it to other comparable organizations. Also that it takes a village. I think that the implementation of a successful evaluation program really requires ownership. But also relevant incentives, collaboration, and support. And I think that for us too, you know, that the need has really driven our services in this area and not the other way around. Also, I think open access is really important to this and something that I wanted to mention. So I really think that open access increases citation, it increases impact, For us initially, it was a really big challenge because we didn't have access to a lot of the databases that indexed our literature. I think that the new OSTP public access mandate is going to go a long way in addressing this, but it's still a challenge for us. And so I really think that encouraging increased publication in open access journals is crucial to be able to do this type of analysis, but also to be able to increase an organization's impact. And also infrastructure is king, so we really had to build this infrastructure to be able to do this well and comprehensively. And also that the available tools and information resources are going to influence your analysis, and there's no way around that. And lastly, that a business model is needed to be able to undertake this work. So we've been working to set up a sort of service model from intake and assessment to request prioritization and a process for triaging these requests. And so I think that, otherwise we'd probably be inundated with requests, and so that's something that we're increasingly looking to do. So very quickly, future directions. So increasingly looking to be able to do semantic text mining. This is something that I think, librarians can do very well. And so I think that this is a promising area for us. Very interested in being able to mine these big data sets that we have, particularly related to regulatory submissions for citation of our publications and other types of outputs. Also looking to more upstream research performance indicators. Publications are, very downstream, and so for us, we'd like to be able to have a broader diversity of measures so that we can represent our impact and not, 2 to 3 or 5 years out. COI minting, I think, is very important for us. This is something that we're trying to do. This is going to be really helpful for us to increase the capture and tracking and ultimately analysis of our diverse research outputs. So we're going to be implementing the COI minting service to be able to mint COIs for data sets, for software code, 3D and computational models, for simulations, for images, et cetera, so that we can do more comprehensive analysis. We're also very interested in altmetrics. That's something that we are looking at closely for future implementation. Also, increasing our collaboration with FDA Library. We have done some training with some of the librarians for how to do bibliometric analysis. Chris Belter actually provided us with a lot of wonderful resources, and we've adapted them and helped train them, and that's something that I think we'd like to continue doing. Also, piloting in this next year an embedded service model that's very similar to the embedded librarian model, where we have these hybrid research administrators and information professionals in each one of our divisions so that they can provide more frontline support to our scientists at the laboratory and the division levels. And so that's something that we'll be experimenting with. And I think that having these additional team members is really going to be able to advance our capacity to do more of this type of work. So here's my contact information. I'd love for people to contact me and to talk about this. This is an evolving sort of service area for us, and so the more feedback and ideas, the better. I also wanted to say that I am organizing a webinar on the Layton Manifesto, which is represented in a recent Nature publication, and it's 10 principles to guide more holistic research evaluation. And so I have Dr. Diana Hicks and some of her colleagues joining us for a webinar. It's June 4th at 1 p.m. I don't want to send this out to the entire FLA or Suddenly Listserv because our WebEx will crash. But for those of you who are here and interested, please just shoot me an email and I'll send you the calendar invite. Okay, and so that's really all I had. Thank you for having me, and I hope that this was interesting and useful to you. Is there time for questions? Okay, one question.
What repositories are you using?
So we currently use Pate. It was just the easiest for us to stand up quickly, and it has a lot of really good out-of-the-box features. We are looking to move to Hydra, possibly, and Fedora in the future. But I can tell you, too, that we do have a lot of challenges in being able to use open source software, and that it's something that, you know, we're kind of continuously trying to balance, you know, our interest in being able to use open source software and the benefits that we gain from that, and, you know, just what is sustainable for us from a cost and a maintenance perspective. But DSpace is something that could be installed by a librarian and used by a librarian very easily without a lot of technical training. We set up the minimum viable product of our institutional repository in 1 week. Yeah. All righty. Thank you, everyone.
All right. Now it's our turn. We are Chris Salter and Ya-Ling from the National Institute of Health Library, and Ya-Ling is going to get us started.
All right. Thank you.
Okay, good morning, everyone. My name is Ya-Ling, and you know Chris already. Chris and I are kind of most recent new hires in NIH Library, working primarily on bibliometric analysis. And there were only 2 of us back last year since we started the program. But this year we had a team of 8. Team members, please wave your hands. They support us with different levels of assistance so that we can move these kinds of services along. Okay, so the main goal of our services, of course, is to provide bibliometric or quantitative analysis as a way to support qualitative assessment of publications in NIH, especially the intramural research publications in NIH. Okay, so that is our goal. Okay, so our service model, or the things that we provide, there are actually 2 levels, and what I'll be focusing on is to talk about our core services, and Chris will be talking about our custom services later. Okay, and as you can see, since our main goal is to provide analysis on the intramural analysis, so one of our primary goals is to provide annual reports to the 27 institutes and centers in NIH. So that is an annual report that we have to provide about their publications. So that's the major big thing in our core services. And the second thing, of course, is about training consultation. So that can be in person or online or in class. So these are the 2 major things that we include in our core services. Okay, so what I'm going to share with you are actually our annual reports, what we include in these annual reports. And since this is just our first year, we're still exploring them. So it's kind of like our template so far, but we might adjust or modify them later, and we will have your input. Okay, so basically, we have 4 different sections in our report. Okay, the first section includes the how many questions, like how many publications has been published by this specific institute or center. And the second section is about collaboration. And there are 2 levels. There are the institutional ones, which institutions work together more often. And the second level, of course, is about the individual authors who like to work together more often. So these are the second area. The third area that we look at is the topic analysis. Okay, so that is the research areas those researchers work on. And the fourth area, of course, is about their impact. So these are the 4 major sections that we include in our annual report. All right, productivity, that is the how many questions. Okay, how many publications have been produced by the specific institute or center or IC that we call. So we can look at the general overview, like how many. We can also look at those numbers specific, maybe by journal, if they're interested in specific journals. Okay, or we can also look at like how many papers by specific subject areas, depending on the database that we use. All right. The second area that we work on a lot is the collaboration. As I mentioned, we work on 2 different levels. The first one is institutional, and in here we actually include several different levels of assessment again. the bottom one on your left, you can see that it is the chart that you see a lot, okay, about the institutions that work together. So from the chart, you can see that which institution is a big collaborator of that specific institute. But only based on that chart, you won't be able to see their interactions. To see their interactions, you want to see more than just that chart. So on your right-hand side, that you can't really see from here because the image is too small. That is the network analysis that we did. And to read this network, the first thing that you have to look at the size or the font of the letter, the character. The larger the font means that the more publications. So we use the size to indicate how many publications that institute has. Okay, and then you can also see that there are some blue lines connected with those institutions. Those blue lines indicate their collaboration. So the more collaboration, the darker or the bluer or the thicker the line. All right. So from this network analysis, basically you can see three things. First, the interactions between or among a lot of institutions, and second, their productivity. What kind of a collaboration may produce more publications? And third, collaboration. What kind of a collaboration you will get more citations based on the, remember the lines and the thickness of the color, the lines. So three things are represented in this type of network analysis. All right, and then on your top left, this is a number that we kind of aggregated looking at what kind of institutions usually is being estimated in this collaboration. For example, we look at universities, how many universities work together with this institute, or how many other institutes in NIH work together with this center, or what about other agencies. So these are some of the general estimates that we include in this little chart as well. Okay, and the second level is about the individual co-authors. Okay, so here you can see that there are actually kind of like two major clusters, and each cluster represents the authors that work close together with each other. And again, the larger the font, the more publications the author produced, and the thicker or the bluer the lines, the more collaboration between them. And what I find really interesting is that other than all of the things that I talked about earlier, production, productivity, collaboration, interaction, you can actually also look at some gaps or maybe bridge. For example, in the middle of these two clusters, you can see there is an author called Liu, who was kind of like a single author, but bridged these two clusters. So it may mean that she or he has specific expertise that can be used to bridge these two groups or two clusters. So it's one of the things that you can really find when you look at the chart or when you look at other types of displays. So that's one of the reasons we think that network analysis can really help us to identify different collaboration strengths. All right, the third area that I work on is research topics. How do you usually do to identify research topics? We look at keywords assigned by authors or publishers or databases, right? Yes, but how about just let the paper speak for themselves? So this is where we use two different levels of analysis to do some sort of text mining thing. Okay, the first thing is that we cluster the papers together based on how similar their references are. So this is kind of a way to look at their shared references, because one of the theory is that if two papers share some references, they may be about some related subject, right? So the more shared references, the more similar they may be, or the topics may be more related. So the first thing we did is that to cluster a group of the papers by their shared references. So that's the first thing. And the second thing is that once the clusters were identified, we do text mining on their titles and abstracts to identify the most recurrent words, and then to consolidate them into one specific concept to represent the research topic of that cluster. So that's what we do for the research topics. So for the network analysis one is the cluster. Each color represents a cluster, all right? And then we also identify the topics based on the text mining, which you can see that is on the chart on the right. Okay, and we also have the line chart to look at the development of those topics. So you can see that probably as a trend or maybe to see some possible development. So these are what we do for the topic analysis. The last section of our report is about the citation impact. Okay, so basically we want to see the ranking or the rating of the publication. And as you all know that when we look at the average or the publication count, we always skew the data because citation is not the normal distribution, right? So we don't want to look at the average. We don't want to just look at the edge index. We don't want to just look at the publication count. And one of the best way that is being introduced in literature is to look at percentile rank, and that is also the method that we adopt. So we look at the percentile ranks, especially top 1, top 10, top 20, and top 60 in each of our publication data sets, and then to identify their identify their percentile ranks, and then consolidate them together to look at like how many top 10 papers they produced. So in this way, we can actually compare different disciplines or publications from different areas. And we think that it is one of the, probably the best ways to normalize the difference between disciplines. Okay, so these are the major bulk of our analysis included in our annual report. And then Kristi is going to talk with us about some of the things that we did for the custom services.
So as Ya-Ling mentioned, we do quite a lot of custom work as well. So in addition to providing these fairly basic profile reports for each of the institutes and centers, we also do some very custom work where the researchers will come to us with a specific question in mind. And so we'll design an analysis to try and address that kind of question. So I've got a gallery of examples of some of the kinds of projects that we're working on to kind of give you a flavor of the types of things that they're asking us for and the types of things that we can do for them. So this first example is we were working with the National Heart, Lung, and Blood Institute to look at 30 years of their publications on obesity. So they were interested in looking at what they've produced via their extramural grant funding on obesity, and they were interested in looking at what the major subtopics were. So within obesity, what were the focuses of this research? What were the major publication sites of this research? And also, how has this research changed over time? How has the focus changed? How have the emphases changed as obesity research has developed over this 30-year time period? So again, we've used the similar types of topic analysis that Ya-Ling just described. And then we basically just looked at the number of papers per topic per year to get a sense of how that's changed. And again, we can see that there were definite shifts in this portfolio over time. So in the early 90s, all the way up until about 2000, there was quite a lot of research in purple, but then that largely faded starting in about 2001 and moving forward. We also see a major increase in the total number of publications starting in about 2007, 2008, and this is really a diversification of the portfolio. It's not necessarily they added more publications on a particular topic, they actually added more topics to the portfolio. So those are the types of things that we can kind of look at, and then we're going to then go back and compare these results to some more qualitative information about what the priorities were about the grants that were funded, how the obesity research landscape in general has changed, and all of that. So that's one of the things that we're working on. Another example is we were working with the National Institute of General Medical Sciences to look at how much collaboration there were between funded centers. So this NIGMS funds a system of about 20 centers located in various laboratories across the country. And they all do work on a very, very similar topic, in this case on systems biology. So they're interested in learning to what degree are these centers actually working together, because they're all getting funding from the same place, and they're all working on the same thing. So are they actually working together? So what we did is a co-authorship network where we actually color-coded the connections between authors based on the center with which they were affiliated. So you can see the blue cluster down there is one center, the orange cluster is another center, and so forth. So as you can see, most of the collaboration happens within the centers. You know, there's not a whole lot of lines going from center to center, but there are a couple. You know, you can actually see where those are based, again, on those lines, those color-coded lines, to see which centers are actually working together and the degree to which they're working together. Another analysis that we're working on is we're working with the National Cancer Institute to do some of the similar kinds of scientific technology roadmapping and forecasting that Jessica was just talking about in the previous presentation. So what they were really interested in is looking at the use of nanotechnology for cancer treatments. And they were really interested in looking at the entire landscape of literature on this topic, not just what they've produced, but what's happening globally. So what we did is we pulled about 5,000 publications from 2014 to look at what the major research directions were in this global landscape, not only to see where the publication emphases were, but also to look at where the citation emphases were. Because if you have a high number of citations in just the first year after publication, that's an indication that this might be a growth area. This might be an area that might be pursuing some really promising research, so that NCI can then use that information to put out proposals for research in this area, to really kind of get ahead of the research and fund the things that are being the most promising. The final example that I'll talk about is not necessarily related to research and impact evaluation, but I couldn't resist including it because I'm talking to a bunch of librarians. So one of the other things that I'm really interested in is how can we use these analytics to do other things that we do normally? How can we improve the processes that we're already doing using some of these analytical techniques? And so what I'm showing you here is a method that's very much in process right now, where I'm using the citation relationships to identify new papers, to essentially use citation mining and citation clustering as a literature search technique to find additional publications about a particular topic. So starting with a couple of papers here shown in red, we can generate a new list of new publications that may or may not be relevant to the topic. And the green dots here indicate papers that are actually relevant to these red papers. So there's some very preliminary evidence here, but it seems to be a very promising method of going about things. I've got a paper to JASIS about this, so stay tuned. If you're interested, come and talk to me. Finally, whenever we do one of these kinds of presentations, we always get asked about what tools that we use. Again, these are very, very similar to the tools that Miss presented, very similar to a lot of the tools that a lot of other people are using, but we're just sort of taking them in that next step. And so we've kind of organized them by what we use them for. So the metadata comes from a lot of the different places, like Reporter, which was mentioned earlier, PubMed, Web of Science, Scopus, all kinds of these other things. Data cleaning, again, as mentioned, we use Google Refine or Open Refine. It's a great software for that kind of thing. For network analysis and visualization, we use the science tool or Sci2, and then visualization in Gephi. For text mining is something that we're sort of growing into. We don't do as much of it right now, but we're sort of moving in that direction. We use not only Sci2, but also an open source software tool called Inspire. Bill actually showed a visualization from Inspire in his presentation. We're also looking into moving into R and some of the more complicated software, but again, the learning curve is very, very steep, and we do not have a lot of time to learn. So it's kind of still one of those wish list tools that we're going to use at some point. We're just not using it yet. So that's all we have for you today. We'll be happy to answer any questions.
How long does it take?
be honest, we can actually produce one of those in about a week. We can actually do that in about 40 hours. But again, that's because we're very familiar with the tools, we're very familiar with the process, we have sort of a lot of experience doing all of this, so we're a lot quicker than we used to be. It's one of those things that as you practice it, you get a lot faster in doing it. So we're a lot faster about it now. I would not suggest that it would take 40 hours to do, but that's just kind of our process.
It also depends on how big the data set is.
Yeah.
If we have to deal with thousands of articles, maybe more than 3,000 or 4,000, that would take longer.
Tell us a bit more about Inspire. You mentioned reading.
Yeah, so a little bit more about Inspire. It is developed by, I think, the Pacific Northwest National Laboratory. I'm not sure. Yeah, in the Department of Energy. It is, again, a text mining tool. It is an open source software tool. So basically, you just plug data or plug a list of papers into the tool, and it will automatically extract clusters based on similar keywords.
It is not available. It is not a reasonable price if you're not a government contractor or a government.
That is a good point. Yeah, that is a good point.
Something like $30,000 you're not. I mean, I think they just don't want that.
Yeah, so the point was made that it is free for federal agencies to use. It is not, however, free for anybody else, unfortunately. So it is there's quite a lot of cost associated with the tool if you're not from a government agency. So just to clarify that, thank you for that point. Any other questions? Yeah, from the phone.
Can you, oh, wait, they're coming in like crazy. Hold on. Hold on. Okay, can you further explain your data cleaning process with Google Refine?
Sure. So the question is about our data cleaning process with Google Refine. Basically what we do is we download the data from Web of Science. We parse that into a CSV, and then we upload the CSV into OpenRefine. What OpenRefine does is it uses a number of algorithms to try and identify similar text strings. So if you've got DOJ or DOJF, it'll say, are these the same person, or do you think these are the same person? And so you can basically just click on a box to say yes and then merge them. So it's a much more robust and much more user-friendly way of cleaning up very messy data.
Yeah. Another way that I have used is to just actually use the data laboratory in Stacy. I'm not sure if you're familiar with that. Anyway, you can also store your data in Stacy, and then you can manually group the similar ones together and then clean them. So there are a couple of different ways that you can do it.
Let's go to one person over here.
Yeah, I just wanted to share that there is an R class at Coursera right now
Yeah, so the comment was made that there is an R course on Coursera. There's actually a whole series of courses, the data science specialization on Coursera, which is a really great series of courses. We just haven't gotten around to taking them yet. We definitely want to take them though. So yeah, thank you for that.
Would you and some of our other speakers be willing to do webinars or hands-on, sit-down, face-to-face training on some of these sort of techniques?
So the question was about whether or not some of our presenters were willing to teach webinars and share some of the experiences that we've learned. Speaking for us, I can say absolutely. We're interested in doing that. We're happy to do that. We'll probably be working with the Scheduling Technology Working Group to start making some of those courses available. And we'll be in touch with other speakers today to see if they're also interested in teaching some of their techniques. So yeah, that's definitely going to be coming. Question from the public. Yeah.
How do you control for growth of the literature as in your data chart from the obesity study?
So what we do, the question was about how we control for the growth of the literature as in our obesity analysis. So what we basically do is we look at both the total number of publications produced on obesity and then compare that to all publications produced by and with NHLBI funding. So we're going into a much more specific look at the data to say, here's the percentage of NHLBI funded publications that are about obesity. So we can, again, sort of control for the fact that the pace of scholarly publishing is speeding up. Yeah, so we've got time for about one more question. Yes?
I wonder if you could share the impact of the type of work and how some of the other participants who maybe don't have the type of thing going on with their organization might be able to convince others how valuable.
Sure. So the question is about sort of use cases and talking about how people are actually using these analyses. So I can speak to the National Heart, Lung, and Blood Institute example. They're using this because we fund a lot of extramural research, and we want to make sure that we're actually making wise investments for that research. So we're really interested in working with not only the stakeholders involved, but also some of the grant managers who are funding research in this area, so that they have more information about what has been successful, what publications they were expecting to see but might necessarily not have seen. So that was another one that we were interested in. So they were expecting to see a couple of clusters that didn't actually show up in our analysis. So that's something that they can move forward and take back to their grant managers to say, these are things that we need to emphasize, these are things that we need to fund more research in order to get some of those impacts. We can also talk to some of the intramural laboratory uses. Some of them are for, again, focusing research to make sure the published research actually aligns with their strategic initiatives. So, you know, each of the laboratory has a set of strategic objectives that they're interested in pursuing, and so we can actually align those strategic objectives to what was actually produced by the laboratory to see if there are gaps or to see if there are things that they need to focus on in some areas and less so in others, or if they're producing research on a particular topic that they weren't even aware of necessarily, but it might be some very impactful research. It might be something that they want to continue to pursue in the future.
Also, you know, I think for us probably it's a no-brainer that libraries should be doing this, but how do you make that argument, you know, and how can a library make the case for dedicating 2 FTEs like the NIH library does to doing this kind of work, and how are you assessing the value that the library is getting out of that?
Let me share with you a short story that I have. That when I presented one of my annual reports to one of the institutes in NIH, they said that they were shocked to look at the findings because that was totally different from the things that they did. And when we talked further, they realized that they actually used the wrong method to evaluate their publications. So basically, what librarians can provide is actually a very accurate method or methodology to do publication analysis. And one of the most common errors, which is probably very easy for all of us, but not that easy for those scholars, is that they do not know that publications have to wait at least maybe 2 years to let their citations to be accumulated. So they do their citation analysis up to 2014 or 2015. And that is not fair to those scholars. And another error that happened a lot is about the comparison of H-index. And as you know, that H-index can only be compared within specific disciplines, and they actually are in favor with those senior scholars because the older you are, the higher H-index that you have. And another thing that happened a lot is that they ignored the importance of normalization between disciplines. For example, the percentile rank. A lot of times they just totally overlook the importance of that. So I think one of the important roles of us as librarians is to let us know that there are accurate or better ways to assess their publications and to give them better assessment of their publications. So I think that would be one of the major impacts of the library.
If I could just jump in one other thing. The other thing that I think we really have going for us as librarians moving into this space is that people trust us. People trust us to provide, this is a big deal. This is a really big deal. People trust librarians to provide accurate and unbiased information. We are affiliated with any of the laboratories that we're evaluating here. We're not actually part of any of these laboratories. We're a neutral third party. And so that's really important when you're talking about evaluation. You want to make sure that the information is unbiased as possible. And we already have that trust built up over generations of librarians. And so that's another one. It's something that we can really use to our advantage and to really sell why librarians should be in this space, because we're going to give you the accurate truth. We have no interest in biasing the results, and I think that's a very important point to be making here. So I think that's all the time that we have. We're going to go ahead and take a break for lunch. So we'll reconvene here back at a few minutes after 1 o'clock. Thank you all very much.
We're good.
All right, I think we're going to go ahead and get started again for our afternoon program. You could take your seats to settle and everything. So this afternoon, we're really going to shift gears a little bit. So in the morning, we heard from a lot of federal and government librarians. Now we're going to shift gears and hear from a number of academic and research librarians. So we're now going to start off the program with Kristi Holmes and Karen Gutzman from Northwestern University.
Thank you, everyone. It is such a pleasure to be here today. This is such an important and interesting topic to us all, and I'm sure I speak for all of us when I say that I've already learned so much more than I imagined possible, so thank you. So I'm going to talk to you a little bit today about some of the work that our library is coordinating on our campus, specifically through our Clinical and Translational Sciences Center. And then Karen will follow up speaking about some of the specifics about the work that we're doing within Gulcher Library. So as you all know, libraries are changing, and I think that this is evidence that we are all up for that challenge. The Feinberg School of Medicine has a bold vision to transform the library into a next-generation information hub where library and informatics services keep pace and help advance leading-edge patient care, research, and education activities. To achieve this vision, campus leadership integrated Gulcher Library with Northwestern University Clinical and Translational Sciences Institute, also known as NUCAS, in July of 2013. This close relationship is, as far as we know, the only one of its kind in existence. The benefit of this partnership has been immediate and meaningful in terms of how we're able to rise to meet the vision set before us towards service delivery and integration with the academic, research, and clinical enterprises. And there's the link to Gulcher. And of course, we have our own web partner site. So this is a really good example of some work that we did to understand the impact of NUCAS in preparation for our Clinical and Translational Sciences Award proposal that was submitted in January. We leveraged bibliographic data from library resources and were able to learn some interesting things about our institute. Here we see that there were 974 medical scientists that were supported by NUCAS funding. The work in these manuscripts was cited almost 17,000 times and across 124 countries. As you all know who are familiar with bibliographic metadata, this is something that's very easily found in the metadata and was able to help our institute tell an important story. So we often hear this phrase, library as place, but I want to concentrate on the library as partner. This is an illustration of the organizational structure of our of NUCAS, where of course we can see governance, strategy, tactics, and operations. Down in the center area, you see Gulter Health Sciences Library. And then over on the right, we see Evaluation and Continuous Improvement Program, where we actually help to evaluate and look for opportunities to improve the activities within UCAS. And this seems to be a really good space for the library to fit. So, what is translational science? I'll just quickly go through this. So I think we're all familiar with a paper that was written around 2000, where they stated that it's almost 20 years from discovery to dissemination for successful therapies into the clinical arena. Now that we've gone 15 years, we see that time shortening to 7 years, and I think it's a lot because we're smarter about what should go through the pipeline and how to catalyze these kinds of activities. And we also understand that translation is more than bench and clinic. It actually needs to disseminate into the communities to result in improved health of our communities. This is catalyzed by the National Institutes of Health within NCAT Institute through the Clinical and Translational Sciences Award. This is a consortium of over 60 universities. And there's specific emphasis placed on local activities that support preclinical development, enhanced clinical trial infrastructures, and community-engaged research, as well as educational activities. Here in this diagram, you can see the types of activities that are happening in translational science, where we see everything reaching across that translational spectrum. And I want you to pay particular attention to the arrows at the bottom of the image, because you can see how this all feeds back to spur new bench research. This particular slide is, I think, a really good depiction of the types of activities that are available for us to think about in terms of evaluation. And I'd just like to point out, I'm very glad these slides will be made available because I'm going through them very quickly. What I want to talk to you about now is building an ecosystem. So how are we catalyzing in the library, evaluating this massive, massive institute? Well, there are two main parts that I think help to build this infrastructure. One is our metrics and impact core that we recently launched in the library, and which Karen will talk to you about here in a few minutes. And then also, I want to point out the clinical, the Center for Data Science and Informatics, which is facilitated by Justin Theron and his group. So this is what the informatics infrastructure looks like at UCAS, and you can see it's a pretty intense group of activities. Of course, we've got a lot of things that are related to the clinical research enterprise, lots of really fantastic data and systems on campus. And then the items that I've circled in the orange indicate those points where the library intersects with these activities. So, of course, we're developing reports and visualizations. We do a lot as far as analytics and data visualization. Of course, we're stepping up with research networking and team science in terms of the representation of research information in semantically compliant ways with our Vivo instance. And, of course, our much-beloved bibliographic resources. And then a brand new digital asset management system or repository that's built on the Fedora Hydra stack. Our repository will house a diverse range of scholarly outputs beyond manuscripts, such as protocols and lab manuals, consent materials, patient education materials, course materials, and so on. And the metadata are available as RDF. And this work is led by Violetta Helix in our library. This is the structure of evaluation and continuous improvement at UCAS, where we can see that there are a number of data sources that are integrated into this workflow. We see the types of things that are happening, and this process by which we evaluate the process itself, as well as those meaningful outputs and the resulting impacts of our efforts. We evaluate this through both traditional and non-traditional metrics and try and visualize and improve them throughout the process. So here we can see some, we think about UCAS evaluation and continuous improvement in the context of some sample metrics. I do want to point out that there are some of these metrics that are indicated with the star are a really good place where we can think about the intersection of library resources toward helping to understand meaningful movement forward toward a particular goal. So, for instance, if we look at the return on investment of our scholars in TL1, T32, and KL2 programs, a good way of measuring that is actually information like bibliographic data. We can look at productivity in terms of papers, in terms of a transition from this development funding into successful R01 grants and so on. So there are a number of things that I think our expertise and resources help to support. But ultimately, we're desperately seeking data. So what do we want? Well, we want a better perspective of scholarly output, of course. You know, and publications are the currency of science right now, whether we like it or not. So we need to take care of that. We want multiple sources. We want to cover multiple subjects and disciplines. We want authoritative sources. We want good data. We want it disambiguated. We want it deduplicated. We want quality metadata. We'd like to know who cares, like who's thinking about what we're doing, you know, what kind of attention are they getting. And then we want a meaningful way to tie all of this to our grants, to our institutional repository, to other institutional effort systems and workflows in a meaningful way. And we want it now. So this is very similar to the image that you saw a couple of slides ago, where we look at these different metrics. And I do want to show you that we have tried to map a number of these meaningful metrics to measure things like process, output, and impact to existing data sources that exist within. So you can see that this is a really nice harmonization between existing institutional systems as well as the bibliographic data and our know-how. It's a wonderful marriage. We leverage a number of methods in support of evaluation and continuous improvement at NECAD. Of course, advanced bibliometric analyses. So we're looking here at leveraging some of our favorite tools. We enjoy the Scopus database, of course. I have really become very fond of essential science indicators. It's available from Thomson Reuters. Of course, Web of Science, and we're going to be doing a symplectic elements implementation shortly, and I'm incredibly excited about that. We'll have all this week. So we are also excited about the role that alternative metrics can play in this realm, not from the metrics themselves, but rather what they indicate, that they indicate there's something interesting happening, and I think it can serve as a really interesting trail toward a more immediate reflection of cool attention toward cool science. Social network analysis is, of course, quite important, and we're fans of the Sci2 tool as well. Surveys, we can't do evaluation without surveys, and qualitative data is important. And then we're also preparing to roll out something called a micro case study, or that's what we're calling it. This is based on a framework that was developed by CABTH up in Canada, which allows us to be able to gather the important and meaningful data that is often gleaned from case studies in hopefully a more efficient way. So I want to highlight what this means in terms of practical reflection. I'd like to look at the Center for Clinical Research. They're doing some amazing work. They do inpatient and outpatient protocols. Of course, you can see a number of services that they do here. And how does this evaluation and continuous improvement reflect and help them consider their work? Well, they have been in the process improvement game for a long time, and they've been able to realize some amazing achievements. They've lowered the institutional costs of the CRU, the Clinical Research Unit. They have a sustainable recharge model. This was either the first, if not the first, one of the first recharge models across the entire CTSA consortium, and it's serving as a model for institutions all over the country. And they're able to monitor investigator usage and satisfaction. And so there's, more and more things that happen there. We're also able to monitor the harmonization of our organization as we become a more unified unit. And I know anyone who's in academia understands that, we're made up of so many different pieces. And so we're trying to do what we can in order to make that smooth and streamlined. This is an example of some of the dashboards that we have available to monitor the clinical research enterprise. We're in the process of rolling these dashboards out across all of our recharge centers, and we'll be making them available for all of the investigators to monitor their facility use, dollars they're spending, and I'd really like to see them monitor compliance in terms of data sharing mandates and my favorite, the open access policy. So just a moment to spend about how we're thinking about impact. I know that we do a lot to count papers and think about paper data, but I do want to point out just quickly how we might consider thinking about impact. This is reflected in work that I was fortunate to do with Kathy Farley at Becker Medical Library at Washington University in St. Louis, where we looked at going beyond publication data to find evidence of meaningful impact along some very specific pathways that you see there to your right. These are the things that actually change the way that we do work. The publications are just an indicator that these kinds of things are happening. And so the publications can actually serve, as a very valuable tool to help you find, what's really happening here. We're planning on using some of the work that I did with Kathy to develop, to map it across a number of other frameworks for representation of contributions and activity in science, some of those being, of course, the NISO altmetric effort, the credit framework, CASRE, the CTSAs are doing a number of interesting things to map and monitor research, Force 11 work, and, of course, Duval. We plan to make structured data around contribution and hope that will facilitate standard workflows for exchange and interoperability with your existing information systems on campus. As few human hands touching the data, the better, in my opinion. But ultimately, we just want to bring it all out into the sunshine. So with that, I'll turn it over to Karen.
Hi, so I'm just going to go over a little bit about the metrics and impact score, kind of a high-level overview. So we launched the metrics and impact score at Cultural Library in September of 2014, so we've been around for almost a year. We serve Feinberg School of Medicine, but we also in particular serve the members of the Clinical and Translational Science Institute, UTAC. And we're building upon expertise that was currently in services that were currently being offered in the library. So we have a team of librarians. Some of them are listed here who are providing some of these services. We just kind of put them under a nice umbrella called the Metrics and Impact Score. And we use that language because the core facilities are the language that people understand when they're looking for particular services for their research. And so if I had to give a really broad overview, how we work in research impact is we help demonstrate, assess, and visualize impact. And those are three very distinct areas. I've listed some services here that are just, it's kind of generalized. We help develop successful publishing strategies, managing or tracking publications, and so on. So we actually serve kind of two broad groups. We have the individuals that will come to us, and also we have the research groups, departments, and institutions. So I listed some kind of very broad examples for reasons so far this past year that we've received service requests. So individuals who are undergoing promotion and tenure or some sort of annual review have come to us and wanted to know more about the impact of their work, or they would like help tracking the research and who's using it. Of course, the new NIH BioSketch has been a big hot topic. And then for the group, the larger groups, advancement of science, how has their work advanced science? Advocating for funding for themselves, also planning for infrastructure, so where is the impact and how do they decide where to continue putting funding? Or just maybe they want to highlight the expertise of a few of their members and also rankings and comparisons. So where are we now? We've had 1 year about, and we have our webpage overview up, which is incredibly helpful. We also have created two versions of what we call our publication summary, and then a product overview, because a lot of the work that we do, in some ways that people ask us is confidential, that we're even doing this work for them. When we want to tell others about what we can do, we can't just send them what we've done for someone else. So we do provide a nice overview so they can see what are some of the things we can offer. And these summaries are very entry level. This is where we start working with the group. So we've established workflows for completing and delivering those so that it's not just one person doing it, that lots of people can do it, and we can do it in the same way across the board. We also have help with publication tables, metrics, and visualizations for grant applications. This is a big area of service, and assistance with the new NIH BioSketch requirements. On top of all this, you have to keep exploring all the data, the metrics, and visualization tools that you have. You have to know what you have and what you can do with what you have, and that takes some time, and you have to put time aside to do that, and it's okay to do that and to take time for that. So this is a quick example of the publication summary for a department. There's just some of the metrics that we can get. Like I said, this is our entry level. So a lot of times people don't know what you can do for them, and so you kind of have to start somewhere. And this is where we start. Oftentimes, once we give out a publication summary, that's when the emails start coming back and we start requesting more in-depth information, and that's where the bulk of your time is going to be spent. So we use what we have available. We have Scopus. We also have Any Scholars, which is Dival Expert, or a version of Dival Expert. We have Other Science, Essential Science Indicators, and then we use what we have openly available to us, but we are anticipating future opportunities with Complexity Development and our digital repository. In order to garner attention around these services so people know they exist, we are lucky to have a director who is very much involved in a lot of large initiatives on campus, and she's able to talk to groups of people about what we do. We also go to departmental meetings. We have the existing liaison relationships, and then also emails that go out. And kind of an interesting aside, so we've actually had requests come in during a presentation about what we can do. And so they come rolling in right away, and we have to keep up with it. So some future directions. We hope to work on some of the educational aspects of presentations, such as enhancing research impact, bibliometrics training for researchers, hot or not making PhD research. These are some ideas that we're going to start formulating, and then further develop our web page or some kind of online resource for our researchers, and then we have the upcoming implementation. Okay, does anyone have any questions? What's Symplectic Elements? Sure, so Symplectic Elements is a product that's produced by a company called Symplectic in the UK. It's a bibliographic aggregator. It deduplicates, disambiguates data from multiple sources. So Web of Science, Scopus, Crossref, Archive, Google Books, and on and on and on. And it pulls all of those in. It's implemented at the enterprise level or at the school level, and it facilitates the workflow. We will feed it legacy data to make the algorithm smarter. So the workflow for our investigators will be an email that says, hey, congratulations, this is your paper, please claim it. They claim it, and then at that point, they will have the opportunity to attach funding opportunity. We find that people have a very hard time remembering all of the ways they've benefited from funding, especially with large infrastructure grants, and so this will give them an opportunity to make that connection where the library can go in and take care of things behind the scenes. They will also be prompted to upload a pre-publication peer-reviewed version of their manuscript directly into our repository at that time, and we'd also like to integrate an opportunity for them to check mark core facilities that they use for that particular output, so that we're just basically getting a better clamp on data at our university. But and the team, the Symplectic Elements team, is fantastic to work with. They're wonderful. Yeah.
So with the Symplectic, have you had any difficulty getting
Sure. So, so the question is, are there problems with engagement by our scientists to do what they need to do? I think that this is very much reflects cultural attitudes within our individual organizations. So we're very fortunate to be in a place that is data-driven and where everybody's on board. And so I don't anticipate this, and everybody's very excited. The people who care about the numbers are incredibly excited. So that's good news for us. But I can imagine in some institutions, this is still just as good of an idea, but it would be very difficult to do. So there's a culture of that, though, in our institution. All right, wonderful. Thank you very much.
All right, so up next we have Terrie Wheeler and Michael Bales from the Cornell Medical College.
Thank you so much, Chris. Ya-Ling, everybody for putting together this conference today. I really appreciate the invitation, and I've learned so much from you already today. So before I take a deep dive, I just wanted to take a minute and set the framework for where we are at Weill Cornell and why we're doing what we're doing. So our philosophy, similar to Northwestern, is to have as few hands touching the workflow as possible. We do focus on the peer-reviewed literature. And the reason for that is when I arrived, I discovered that the library was called upon by the Dean's office to produce quarterly reports on faculty publications where our faculty are either the first or the last author, and the journal is ranked at least 15 or higher as an impact factor. So I thought that was quite interesting. That told me a lot about my organization immediately. So with that in mind, that's where I started to do our bibliometric work. So what I'd like to do today to baseline that, to found it, is to go through a brief history of citation analysis. However, I'll only spend time on what's important, but I can come back and answer questions on anything. Then I'd like to discuss two commonly used parametric methods. I'd like to discuss citation skew. I'd like to discuss publications and citations as easy output metrics, our responsibility given the above facts, use of non-parametric methods, for example, the percentile rank, and building reference sets. And Michael will speak quite a bit about that. So here's our timeline of the brief history of citation analysis. What I want to focus on is 1926. In 1926, Gross and Gross did the first citation analysis of content in the Journal of the American Chemical Society. They looked at all the references for a full year from that publication. They found 242 journals that comprised all of the references, and of those, the vast majority fell into the top 22 journals. This follows the inverse square law of scientific productivity that was introduced by Alfred Lotka, also in 1926. Then let's jump forward to 1934. Samuel Bradford documented diminishing returns of references in science journals, which in other disciplines is recognized as the Pareto distribution. So with that in mind, there's a lot of other activity, of course, but with that in mind, I think it sets the stage for why we're doing what we're doing. So parametric methods of citation analysis. There's two very popular parametric methods that are used today, the impact factor and the H-index. So what is a parametric method? Parametric statistics assumes that the data has come from a type of probability distribution and makes references about the parameters of the distribution. Parametric methods make more assumptions than non-parametric methods. If these assumptions are correct, parametric methods can produce very accurate and precise estimates. If assumptions are incorrect, parametric methods can be misleading. So let's look at the parametric methods we're using today. We have the impact factor, which looks at the average of the mean number of citations received per paper, which is published in the last 2 years of a journal title. And we have the H-index. As Ya-Ling so graphically described, the limitation of the H-index is that an individual with more publications has generally a higher H-index. So it discriminates against individuals who may publish very significant science, but in fact, one of my labs, I had a gentleman who did not publish a PI, who didn't publish for 11 years, but when he did, he published a paper that was extremely impactful. However, his impact or his H-index would not have increased that. So with that in mind, I'd like to talk about citation skew. So one of the problems, as we've alluded to in the history, is that this distributions of article citedness are highly variable, and even for articles written by the same author, as first identified by Lotka and Bradford. The citation variability between articles in a journal is so large that the journal impact factor, or the average citedness of a journal's articles, is not the best parameter for evaluation. Approximately 15% of a journal's articles garner approximately 50% of its citations, and this information is taken by a paper called The Skew of Science by Terrie. I've done a lot of research, and I find that this particular paper really highlights the issue with the skew of the way the distribution of citations occurs. So he also notes that the top 7.5% of those papers account for 90% of the journal's citations. So awarding the same value to all articles in a particular journal, i.e. the impact factor, conceals differences between the papers, and this is counter to the purpose of bibliometric analysis. I have three graphs to show here. The first graph shows, well, all graphs show citations per article per year. We feel that it's very important to look at reference sets that look at articles that are written in a particular discipline, in a particular year, and of a particular article type. And I think Michael will be talking more about that. We also, all these graphs show comparisons within the discipline, as I just mentioned. So this first one is a comparison of two individuals in biomedical sciences. They have the same number of papers, not cited, and they have an actual citation that's very, very different. However, they appear by their mean citations to be somewhat close, but you can see by the actual papers that they're not. The next graph compares the distribution of citations to biochemical journals. It looks at three different journals with three very different impact factors. One journal has nearly quadruple the number of papers of the other of the first one, and these are broken into cohorts. In other words, citation cohorts. In other words, papers that have 0 or 1 citations, papers that have 2 or 3 citations, papers that have 4 or 5 citations, etc. So you'll notice that uncited or one-cited articles represent the largest citation cohort in all three journals, regardless of impact factor. And then the third journal, or the third graph, compares individual authors' mean citedness. And basically, the summary is that the more skewed the author distribution, the better the fit with linearity or the inverse power law of distribution, which was basically Lotka's law that I mentioned early on. So, I've heard it often said at NIH, garbage in, gospel out, and what we meant by that is if we don't have clean data to make good decisions, we are essentially making decisions that become policy without clean data. So how important is that data? Because publications and citations are very easy to count and track, it's very tempting to use citation data as a proxy for impact. So it's our responsibility as information professionals to ensure that we provide absolutely accurate metrics. The skewed nature of citation metrics begs for a non-parametric method to measure it for greater accuracy. Percentile ranking is a non-parametric method that's garnering a great deal of interest and respect in the bibliometric community. And so Michael's going to talk about how we're using that at Cornell.
I'm so glad to be here and to have the opportunity to talk to you about the method that we're using percentile rank to communicate information about researchers' scholarly productivity. Thank you to Kristi for the invitation, and thank you to Holly Philbin and everyone who helped make this workshop possible. So information on Researchometrics is used in very important decision-making processes around hiring, promotions, and tenure, and also grant making. So it's very important for us to communicate this information in a clear and straightforward way. And so when a research paper is cited by other articles, it suggests a stronger scholarly contribution. Now, if an article was cited, say, 3 times, it doesn't sound like a lot, but if the article just was published a few days ago, it might be a lot. So as Terrie mentioned, citation counts vary by field of publication, year, and also article type. Review articles, they tend to get more citations, for example, than research articles. So we want to measure the number of times an article has been cited relative to a baseline. And we reference sets of articles in the same field, article type, and year as the article that we want to calculate the percentile rank for. So the reference sets serve as that baseline. So let's say we have an article and we want to calculate its percentile rank of times cited. Well, articles may be in more than one field. So we actually calculate our percentile rank at the level of individual articles, and we may have one or more reference sets for each article. So I'll explain how we do this, and then I'll show you an example of how this works. So we start by looking at the Web of Science, Thomson Reuters Web of Science subject categories for the article that we want to calculate the percentile rank for. Let's suppose an article is in a journal that's categorized as cell biology and biophysics, 2 categories. So we want to make 2 reference sets. We start with the first category, cell biology. We go into Medline and we identify all of the journals that are tagged with that subject category. We take a random sample of articles from those journals for that year and for that article type. And right now we're using 200 articles, but we're in active discussion with biostatisticians at our university as to how many we should be using. So now that we have this reference set, we look up the number of times cited in Scopus. And then we assign a number to each article, where the articles that are cited the fewest number of times are given, the article that's cited the fewest number of times is given the number 1, all the way up to 200 for the article that's been cited the most number of times. I know that may seem counterintuitive, but that's the way the mathematics works. You would think maybe it should be number 1 for the one that's cited the most. Now, some articles may be tied. They were cited the same number of times. In that case, we take the median of the number that we assigned to the article. I'll show you that in a second. So now each article has a rank. Then we use a formula that was first proposed by Alan Hazen in 1914 to calculate the percentile rank from this rank. And that citation is in the handout. People on the phone have the handout, or they will receive it in the email. Okay, people on the, who are calling in will receive the handout in the email. All right, so suppose this reference set is a hypothetical reference set with 12 articles in it. The number of times cited is in the left column. So as you can see in the next column of numbers, each of the articles is assigned a number. And you can see in the left column, 2 of the articles were cited exactly 3 times, so there's a tie. So we have to take the median between 6 and 7 and assign a rank, an adjusted rank of 6.5 for both of those articles. That was also done for the bottom 4 articles. So once we have all of that rank information, we can calculate percentile rank. So the article that was cited 3 times is in the 50th percentile in this reference set. Now we use the reference set to do a lookup against the original article that we want to calculate percentile rank for. We haven't yet finalized the method, the exact method that we're going to use to do that lookup. Now, as I mentioned, we may have more than one reference set for an individual article, and so we have now potentially 2 different different percentile ranks. And for what we're doing with the visualization, we want just one percentile rank. So we're going to take the average of those, or we may what's the highest. We're still debating about that as well. Now, suppose a given author has published 60 articles during a given time period. We want to represent that information as a statistical distribution of number of times percentile rank of the number of times each of those was cited. So we developed the visualization of this. We went through an iterative design process. And I really like this quote because it's consistent with our design philosophy. One of the key functions of a visualization is to support sense-making by contextualizing information for the viewer. You added a space in sense-making, didn't you? I was thinking about doing that. Holly.
It automatically did it.
I heard that you made some typo corrections. That's fine. So anyway, this is a work in progress, and we're continuing to make changes to it. But what we have now is this iconographic bar chart where each article is, each square rectangle is an article. Gray rectangles are research articles, blue are review articles, and the red flag indicates the median percentile rank for that author for the time period. So you can see that this author has a good number of articles in the upper decile percentiles. So we're binning here. We're binning the articles, the percentiles by 10. Now, the main advantage of using this type of chart is that it allows people to click on individual articles for more detail in an interactive online application. The main disadvantage is that using this explicit iconographic style, it may make people inclined to want to count individual squares, which imposes a cognitive burden that we may not really be intending. And one of the challenges that we have is there are too many articles in one of the bins to fill this. They'll sort of be too big for the space. So what do we do then? We may have to reduce the size of the individual squares if that happens. So we have to do some more real examples with this before we refine and figure that out. Another possibly more significant challenge is what do we do when the data are sparse? If there are only 20 articles in a given time period, do we display that at all? Or do we display it with some kind of caveat that this is sparse data and extreme caution should be used? This version also does not show extremely highly cited papers, like papers in the top 1 percentile or the top 0.1 percentile. So we can make a modification to do that as well. But keep in mind that this is meant to be just one indicator among many that can be used to assess the scholarly productivity. Other things they've been brought up today: teaching, mentoring, speaker invitations, number of patents, distinctions, and awards. One might also like to see a list of journals in which the author is published, or a list of fields in which the author is published. People that we've shown this to are also interested in seeing how, even though this is against the baseline, they still want to see, well, this is one person. I want to see what other people look like, other people in the same department. You might also want to include something about the year of the author's terminal degree, so that you can see how far along they are in their research career. Maybe compare this person with other people in the same field who are relatively as far along in their career. So for a detailed overview of using percentiles to evaluate researchers, I recommend the article which is mentioned in the handout by Bornman and Marks from 2013. So we do have a developer working on a version of this for our researcher profiling system, Vivo. We have a module called Vivo Dashboard, which does some visualization that's under development at Cornell. And this is what we have right now. You can see that there's a pop-up that comes up when you click on one of the individual articles. We're building that out a little bit right now. And we deliberately exclude the most recent 2 to 3 years, as was mentioned earlier today. It's a good idea to do that because those articles haven't had enough time to accumulate citations. So we would really love to have feedback on this. Our contact information is in the handout. And I guess Terrie will come back and give just some concluding thoughts.
So where are we going to go with this? There's a lot of, this feeds into a lot of the work that we're doing. We're looking actively right now at a new faculty information system, and so we want to make sure that we can take that data from that faculty information system, put it through the dashboard that we're talking about, and be able to display the author's content. We're also, and Michael is the lead on working on developing a author disambiguation tool for us, because everything that we try to use commercially just always there's some flaw or another, and we're getting more and more Asian faculty, and so we really need something that's going to work for us today that is not going to take the author and require them to do a lot of data entry. So we're building this tool out. It will fit in Vivo as well, and hopefully eventually that tool will be made available to all Vivo sites for all of you who are also Vivo sites in this room, or on the phone. And then we want to communicate valued information. It is critical that we identify what our constituents really need and value as far as information, and begin to work to develop, as we are doing currently, workflows to produce that information. And I think we saw what Chris and Ya-Ling were doing as well. So that's really critical for our profession. So that's where we're going next at Cornell, and happy to take any questions if you have them, if we have time. Oh, yes. Aren't all the citations? Oh, the question was, what article was I referencing when I was talking about the students of science? I have a fairly extensive, not exhaustive, of course, but I think there's maybe 10 or 12 references or so. And number 16? No. Okay. Great. Thank you. Have we been, so the question is, have we been looking at article level metrics? Article level. Yeah. Everything that we're doing is article level metrics.
Right. Beyond
right. Thank you for that question. The question clarified to all metrics. I was looking at all metrics. So if you recall, when I said, when I arrived, the philosophy or the report that we were doing was based on the peer-reviewed literature, and our administration was interested in quarterly reports on faculty publications with first or last author, and in the in journals that were only impact factor 15 and higher. So that's my audience. That's who I serve. And so at this time, while I agree with Kristi that that's very interesting, Altmetrics provides a lot of interesting information, it wouldn't provide the information that my constituency is actively seeking currently.
I have to make a correction. I forgot to mention that the percentile ranks by convention are inverted. You take 100 and subtract the percentile that you calculate. Why the graphs don't look the same as the reference set slide that I have. Yeah.
Hi, so this is really, you guys have such a fantastic group. You're doing such good work. I'm wondering if you can share with us, I'm familiar with the work that you've done in the Vivo platform, but I'm wondering if you have had the opportunity or how you're delivering this information when people, the constituents that Terrie mentioned, when they're asking these kinds of questions. Do you have reports? Are these done on, on a case-by-case basis?
Yeah. I've been producing these reports manually. It takes a lot of work. I mean, it's probably using the current method 4 to 6 hours for the average researcher. You have to do disambiguation. There's more work as well. And they're actually, deemed are wanting to use this information in decision making. No. So does that address your question?
Yeah, I'm just wondering what the flow is like, and if you have found some standard, like, standard operating procedure, or are you kind of adjusting on a case-by-case basis?
Well, I haven't gotten that many requests yet.
You know, one thing that we're trying to do is we're trying to actually hold off the requests until we get this automated, so that when you know, we turn the crank on and let people know we have this service, we can quickly disseminate it. And so that's why our developers are doing a lot of work around getting this ready so that it's completely automated.
Thank you.
Thank you.
So up next we have Christina Pikas from the Johns Hopkins Applied Physics Laboratory.
Well, what they said, I'm listening to all of these and I'm like, I do that, I just do that, I could do that, I should do that. Anyway, and this is the second one of these that I went to, and I really value it. It's nice to get us all together, and we should do this more often. So that's my family too. So we can do it. Bibliometrics is a library service in special libraries. So I will a little bit later on talk about what ETL is, and I think it's important that, you know, we don't have any students, for example. We're a special library for a research organization. Ease of access to citation data and a maybe natural desire by our scientists and engineers who run our organization, in many cases, has led to unreflected use of ready-made indicators offered by the owners of bibliometric databases. In other words, there's kind of a backlash in the world about unreflective use of journal impact factor H index. Just because it's easy to measure and you can come up with a measure doesn't mean that it's the right measure for happening, as everybody else today has mentioned so clearly. However, and I also make the point that librarians are ideally suited and situated in our institutions to provide this service in a sensible and reliable way, and that this is a service that we should be providing. So I'll talk a little bit about how and why librarians, and then I'll give some examples from APL. Now, my examples have the actual requests redacted because we do a lot of sensitive work, and I had to get it public release. And then I'll talk about some of the questions that I answered, some of the tools that I use, and there aren't specific slides on it, but I'll talk a little bit about the specific work I've been doing the last few months and what I'm working on right now, which should also tie into the previous presenters. So at first, I think librarians really have this great background that we take for granted, and when we hire librarians, we expect this, but it isn't necessarily obvious to non-librarians, that we have an understanding of scholarly communication. And this just became more obvious. I was talking to somebody who was doing an audit within my organization, and they didn't understand how long it took to get a journal published and then to have it come up in the database. I mean, they just didn't have any concept of how, you know, you do the research, you submit it, it gets peer reviewed, months later, you know, then the journal comes out. And so we know about scholarly communication. We know the difference between book contributions and conference papers, and that conference papers in geosciences are not the same as conference papers in computer science. We know how to do information retrieval in our areas. So how to do a more comprehensive search. And of course, we will never say it's comprehensive, right? We can always miss something. We know how to do more comprehensive searches. We know where to search. We know why Web of Science is better for something, Scopus is better for something, and you really want to be an InSpec or Compendec or ETIC or, you know, DOE, you know, database for other things. We also have to know how to organize and deal with our results. We would maybe automatically think of using RefWorks and Notes, you know, something like that, Mendeley, Zotero, whatever, to organize the citations. People who aren't librarians might not think that. And we also should be, hopefully are, embedded in our organizations to an extent that we're familiar with what
research areas that we work in, where our research output goes, like is it AIA, is it, ACS, where does it go, and what kind of things that we produce. And also what our leadership is interested in and what areas they might want to get into. Hopefully you're helping with the strategic planning for your organization, so you already have an idea. Also, we have access to the data. We license the databases. Now granted, for some of these things you would do better with like a local copy of the database, which I don't think ever have the money to do. That has to come from project funding. We know how to do good search, as I mentioned, and we already know how to manage the citations. But with that said, we have that experience, and that's what we have as professional librarians, reference librarians particularly. But we might need to familiarize ourselves with which calculations to use for which purpose. And also the actual details of cleaning up the data. There are tools to make it faster, as we talked about today. And those not only take somebody telling you about them to know that they exist, but they take a lot of experimentation, a lot of practice, and it's easy to get out of practice, so a lot of practicing, and how to visualize the results. So a lot of the things that librarians are willing to do kind of manually, when you start getting to scale for research evaluation, you can't do it manually any longer. And we also probably need to brush up on the ethics, what to measure and how, and also how to represent the results so that they're clear about what inferences can be drawn from them and what they are reliable for. And we've already heard talk today about the Ya-Ling manifesto, and another similar one like this is DORA. DORA is kind of a backlash against the impact factor. Specifically, impact factor, which was meant to be an information retrieval tool for journals, is now being used to evaluate individual researchers for, so the DORA is you can sign on to that, an impact factor kind of thing. So some examples from ATL, and this is by no means comprehensive. So first of all, I was going to talk about what ATL is. So we're a university-affiliated research center. We do a lot of work for DoD, NASA. You may have heard of Messenger within the news. You may have heard of New Horizons is doing its closest approach to Pluto. Those are our spacecraft that we built. And the library did research to support that work. And I did an instrument bibliography for Messenger. And we have about 5,500 staff. And also, people don't understand where we fit in Hopkins, so we don't always understand where we fit into Hopkins. I don't report to the Dean of Libraries, and my boss does not report to the Dean of Libraries. We're totally separate. Our director reports to the Board of Managers, reports to the University Board of Trustees. So we're part of Hopkins, but we're not part of the medical school or anything like that. And it's also important to notice, this has actually gone down a little bit. We used to be about 76% technical professionals. We're now 72%. And of those, about 20% have a PhD, and about half of those are in engineering. So here's a sample question to answer. In given research area, do university-affiliated research centers collaborate more internationally than government labs? So the hypothesis was that since we are connected to a university and part of a university, that we would be able to collaborate more internationally because we would maybe have more connections or maybe have more immigrants or whatever. So the first problem with this was the research area was very fuzzy. It was huge, and I didn't know what it was. So first, you do a little searching feedback, found a local subject matter expert, and sat down with him for a while and talked about it. And he said, well, really, Czech Republic, this is the kind of thing they're doing, this is the kind of thing they're doing in Japan, this is the kind of thing that, your institution is doing, this is the kind of thing, and this is called this, and this is called that. So it took out, pages of notes. So then use those to search the domain databases. Now, we've been talking a lot about Web of Science and Scopus because they're the ones that give us the citation information, right? But, as we know, Web of Science, neither one of these are comprehensive, and neither one of these has human-aided indexing, and a good, clean thesaurus. So InSpec has a beautiful thesaurus, but it's narrow in scope. So and it doesn't have the citation information. So, you know, as a librarian, if you're just trying to find articles on a topic, you would know to use InSpec, but it doesn't help you with the citation data. So, but I use the domain databases in this case, particularly InSpec and Compendex, because I wanted to find co-authorship networks. And then I also did keywords, country, and institution graphs. So what keywords appeared with which country of, probably the first author country. And then I kind of went back and checked with the domain experts. Well, it turns out that, in fact, no, because when we're actually prevented from communicating certain things internationally as much as anybody else. But it was an interesting thing. This is just not meant to be readable. Just a picture. And then this is also not meant to be readable. What this is you have countries, and you have just words like Gaussian distribution, speech intelligibility, heuristic programming, you know, so what countries are using which terms? Okay, so that was one example. We've done a few that are kind of like that. I would say we is actually me. I don't have a team right now. We've gotten smaller. My library has gotten smaller and smaller and smaller and smaller and smaller and smaller. And so now I'm the only one doing this part with my other duties. So somebody came to me with a pile of records. Boom, in a CSV file. Like, I don't know where it was from. They didn't want to tell me where it was from. and it was like Unicode encoding. So if anybody knows about, you know, encoding, did not know before this what's the problem. So, you know, a comma's not always a comma, it's depending on Unicode and 3 or 4 different commas. Okay, what can we say, given this data, what can we say about this, you know, country's published research in this area? And I don't know, see, when I do the search, I kind of know what I kept in, what I kept out, what keywords I used. I was actually able to figure out what keywords they used based on, like, these keywords appeared in, like, every record. They clearly searched on that. Who are the primary researchers? What are the primary institutions? How much collaboration is there among institutions and internationally? What methods are associated with what terms? And so that ended up being really just keywords and then kind of pulling out things that were actually methods and versus phenomena. And then what are the trends over time? So that was kind of tricky. And then another example is collaboration at APL. And we've done, it's been a big thing, collaboration and innovation at most organizations, ours included. And so what is the level of collaboration among departments? And we also did other social network analysis, like charging. You know, if you're charging to budget, how many different departments are charging to the same budget? And that also has, you know, certain innovation or intervention that they did changed collaboration patterns over the years. So, and then beyond that, I do, you know, instrument bibliographies, H-index, you know, where some asked for it, you know, cited, you know, collection, development, questions, grant, standard, stuff like that. So tools used, CyQ, CyQuery. Nobody today mentioned Vantage Point, I don't think. I know Alan Porter was here last year, I think. And so Vantage Point is it has a 1 asterisk, as a star next to it. It's a license for money. Vantage Point I use for, I also use OpenRefine, but Vantage Point is really nice for cleaning up author names and conferences. If you're doing something, like when I was using InSpec and Appendix, I had conferences in there too. So cleaning up conferencing, things like that. It does a lot more than that. Also, I don't think anybody today has mentioned UCINet and NetDraw. I mean, it's really interesting because I think these are the standard tools, and it's interesting that I'm the first one to mention them. So UCINet is a standard social network analysis tool. You license it, but you can get NetDraw for free, I think. And iGraph in R. So I like saying R because I sound like a pirate or something. So I actually successfully use R. And but I'm always learning with it. So I'd be very happy to join a group of people who want to learn together about R. and Payak, and Inspire, and I didn't spell Inspire right. And yeah, so I did this check, and Inspire is really available to government contractors. You know, we're doing work for the government, and it's priced so you can't get it ever otherwise. Also, I do have a lot of recommendations for Note Excel, and people have recommended Note Excel to me a lot, but my employer, my computers aren't set up where I can actually install it. It's an add-in for Excel. So it might be easier for some other people to start with if you're comfortable in Excel. So I want to encourage that. And I've never had any success whatsoever with Gephi, so I'm always intrigued with everybody else. So. Using it. And I want to say, so when I'm doing that, I don't have any concept of time, so I'm hoping you guys are following me. Okay, so my next task, what I'm working on right now is not using Web of Science subject categories, but actually doing fractional counting and using Hazen percentiles for that. So the problem with Web of Science, there are many flaws with Web of Science categories, and they're good for certain purposes and at certain levels of analysis. And for example, APL does a lot of work in acoustics. If you look in Web of Science and acoustics, and in the Journal of the Acoustical Society of America, it has audiology, it has designing of theaters, and it has underwater acoustics for looking at submarines and looking at whales, you know, and whatever else. And if you think about it, so the audiology people, speech pathology people, cite like biomed, the people looking for submarines, cite like engineers. And so what you have with that area of acoustics is just kind of a mess. We also do a lot in optics. Optics is another area that, you know, has some very physics-y, some very engineering-y applications, some biomed applications. So I find that those categories, unfortunately what happens with APL is if you just use impact factor, if you just use number of citations, all you get is Messenger, and you get New Horizons. All you get are spacecraft that are on the front cover of Nature and Science. That's all you'll see. You won't see the rest of the contributions of the other 5,000 people. And so, this fractional counting, instead of +1 for every citation you give, if the article doing the citing has references a total of 50 articles, you only give it +1/50th. So that review articles give a lot less contribution than article in engineering that only cites 8 articles will give a lot more contribution. So that's what I'm working on right now. The other big thing that I'm working on is trying to go beyond just using the metadata and to do more in R with like text mining and coword. And the other thing that I find people from other government organizations might agree with me that I'm extremely uncomfortable with putting any data on like a web-based service, like a free version of Tableau or using Wordle or anything like that, because my information all has to go through a review process before it's released. So I actually put it on my blog, and I could send a link to it. How to do, you can use in R, you can do a word cloud, you know, and it's all local on your own computer, and you're not sending your data out anywhere. So a lot of what I've been trying to work on are methods that I can do that I can, and I do use RefWorks some, but I have to make sure I don't use it for anything sensitive. You know, methods that I can use local to my own computer using more of the full text, or at least the text in the abstract instead of just the metadata. Those are techniques that I'm using right now. And takeaways. I think librarians can and should leverage their information science subject and organization, as far as not organizing information, but the information about their organization, knowledge to support bibliometric activities. There are many interesting and important questions to answer. There was really quite a diversity of different tasks that we're all doing with bibliometrics here today. But I think that it's important that we keep attending these events, and we do, and there's a lot of self-study and experimentation required. And I find that if I set it down for a minute, I've already forgotten it, so you have to be continuous. And I would definitely be happy to, you know, collaborate with people on figuring out how to do these methods better. And that's my contact information. I'd be happy to answer any questions I can. Please. So the question is, what do you need to study besides library and information science to do this? Well, you know, and I think that I keep thinking that I'll find like the magic thing, and you know, it's not there. I've been on the Sigmetrics list for many years, and or quite a few years, and they fight amongst themselves, and I find it absolutely hilarious because I find that librarians are so polite, you know, and we always say, well, they must really. But those guys just hit and punch, and you're screwed up, and how could you count that? And you can't use parametric here, and you know, whatever else. So I find that, in fact, these people don't know everything. They're citing each other to each other, and so there isn't a point where you will be well read. And I keep thinking I will get to a point where I will be well read in this area. But I've read lots of articles. I actually recognized Fast and Dirty. They went on the applications there. But so I don't think you don't need general statistics. You don't need to go and get a degree in statistics because a lot of this is not statistics. And I think that it's more, and you can very easily get into the weeds on, you know, if you start going to JASIS and Scientometrics Journal and Journal Informatics, you can start getting into, you know, you get into these battles with the experts about, you know, whether percentile counting versus, I mean, the one today is about using, instead of web of science categories, using clustering to come up with the categories. Then you come up with 4,000 categories, and 4,000 categories aren't meaningful. And, you know, and they're not transparent, but if you do clustering, anyway. So what do you need to study? And I think that the answer, I don't know what the answer is. And, but I know the answer is not doing a lot of statistics, because there's not a lot of statistics involved. Because we don't want to use parametric things as much, right? Because the skewness, because, you know, you're assuming that it's a normal distribution, and it's not. And yeah, I mean, something that I'm trying to do right now is doing group-based trajectory modeling. It sounds exciting, except for I'm just going to try to use the package in R and hit the button. And I didn't. It didn't work last night. But anyhow, so I don't think. I think the thing is you have to kind of try something, and I think playing with the tool, spending a lot of time playing with the tool, and Googling for answers with the tools, I'm looking at Stack Exchange a lot. I don't think that, I think even if you were completely up to date with everything going on in the field, reading the big journals, it would not help you. I mean, it would help you some, but it might get you more confused because then you not know which measure to use. And that didn't help you at all.
I would know.
Yeah, and certainly. Yeah, I mean, I think that, you know, Elsevier and Thomson Reuters both publish information, like, you know, journal indicators about their SNP indicator. Simego publishes information about why theirs is wonderful. And then you can just take each indicator and look it up in Google Scholar and find all the people who think it's wrong for some reason and read and see if that makes sense. Yeah. Yes, please.
The first tool that I tried to use turned out to be a good disaster. I have a Mac, and I was trying to use Good Excel.
Oh, yeah.
It's not. There are even is there a tool we should try to start with if we wanted to analyze our country bibliographic record?
All right. So the question was, you know, trying a couple different tools, tried BibExcel, and on a Mac, it just didn't work well. And BibExcel is pretty old. I don't think it's been updated for a few years, and it's meant to run on Access. You know, Microsoft Access. So I think, I would say Sci-Squared for sure. If you have to start with one thing, and what I don't think was mentioned before is they have a wiki how-to manual for Sci-Squared, which has recipes in it. It's like, okay, you want to look at this level, you want to answer this kind of question, get this data from this database. In this format, hit this button, it should look like that, it should look like that, it should look like this, it doesn't look like that. You know, and it's actually, and that kind of cookbook is so useful. So I would recommend Sci-Squared for that for sure.
So just as kind of a funny aside, I've been emailing with Patty Warner most of the day today, and she suggested that there's a visualizing information book that they put together in the context of their MOOC. It's awesome. And so that would be a really good way to get started if you don't have the time to commit to the MOOC right now, or you don't, maybe just want to get a feeling for what the possibilities are.
I'll just repeat that real quick for the
Yeah.
I'm on the microphone. You pointed out that Patty Warner had suggested that they got together a book that had to do with the course materials from the MOOC that they did transformation visualization at University of Indiana University. Has a MOOC that they run, I think, in spring January. And they have a book that's freely available that you can get that has information on that as well.
Exactly right. The book actually takes you to the exercise, and it shows you step by step what it should be doing in school. And if anybody is interested in sort of doing that together, we find we can
Anthony suggested we could get together and do it all together. And the book also walks you through the exercises. Repeating for the people at home.
Could you talk a little bit more about
Fractional counting, yes. Fractional counting. So, in other words, usually when you say something was cited 10 times, there are 10 articles that point to that article because they found it useful or they wanted to point out how screwed up it was, or for whatever reason they do the citing. So, visual insights, a practical guide to making sense of data is the book. Anyhow, so when you do that though, that makes every citation of equal value. So what I'm doing instead, and I didn't invent this method, this is suggested by Dr. Leasor, is that I'm saying, okay, Article A is cited by Article B. B, in turn, on its own, has cited that article as one of 50 articles that it's citing. So instead of saying +1 on the original article, I'm saying +1/50th. And so, okay, and then Article C only cites 8 papers and is one of them. So it gets a +1. So what happens is, if you're in a field that every article cites 50 other articles, you're not going to be as inflated. So for engineering, for example, for Space Department, our scientists act like scientists, of course. Our engineers in the Space Department might, for their whole entire spacecraft build, which they solved all kinds of problems, did all kinds of crazy things, never been done before. They might have one article that cites 5 other articles, and then in turn gets cited once or twice. Because people use the data and their output is the actual spacecraft, and the fact that it's successful at Mercury, in Pluto, whatever else, is the output. So it's not the publication, it's not the output. So in other words, it would not penalize them as much, because if each of the articles they're citing only cites 5 other articles, they'll get 1/5 for every one, as opposed to 1/50th or 1/30th. So that's the idea. Now, I don't think, so I have done this, I've done it preliminarily for the 1,000 articles ATL's written that are in the database with ATL's name since about 1975 in the Web of Science. And I did it for the top 1,000 articles. And I found that it's still, science and nature are still going to overwhelm everything. Spacecraft things that, are in front cover of science are still going to overwhelm everything. But it does pull out a lot of the things that were like algorithms on how to successfully do, signal processing algorithms that were super important, and a review article on K-means clustering and stuff, popped up where it wasn't necessary. So that's what practical counting is. And I hope to actually publish that, but I'm still at the data analysis. You have to wait.
So up to this point, we've been mostly focusing on librarians who have been doing things at their libraries and sort of looking retrospectively. We're now going to pivot a little bit, and we're going to look a little bit prospectively to look at, what things may be coming down the line or other ways that we might want to look at impact and evaluation. And so for that, we're going to have Rachel Borchardt from American University to look a little bit more broadly about altmetrics and other ways of assessing things.
Thanks for that, because I was going to say this is far less technical than what we talked about.
And that really represents where we are with altmetrics, I think. I like to think of it as we're really in the communication stage right now. We're trying to get the word out to our researchers about altmetrics, what it can do, what it can't do, what exactly it means. So what I want to do today is talk about what's happening right now with altmetrics, what are some recent developments, how our library is currently working with and supporting altmetrics, and my take on what's next for altmetrics. So very much more basic. So bear with me. I'm kind of assuming that people are generally familiar with altmetrics, so I'll just kind of touch on some key aspects. Starting with a definition for altmetrics. I'm not going to read all of these, but there is no standard definition for altmetrics. I pulled one from altmetrics.org, which produced a manifesto in, I think, 2010, along with Wikipedia. And then just to round things out, I put my own definition because in terms of communicating with researchers, I find it very simple just to say this is going beyond citation. But what exactly is considered altmetrics versus existing bibliometrics? So, for example, book metrics, where does that fall? Or page views and downloads. We've been looking at that. Is that bibliometrics? Is altmetrics? So you might want to think about what is your definition of altmetrics, and that can help inform how you communicate with your own researchers. So altmetrics is a fairly large umbrella term, and just as there's no standard definition, there's no standard way to start breaking that down into categories. There are some major tools that are used in altmetrics. I didn't list them here, but 3 of the major companies that are involved right now in creating tools around altmetrics are PlumX, the altmetrics suite of products, and Impact Story. And they all break down altmetrics into different categories. I chose PLOS, which also has their own categories for how we start to break down these different metrics. But ultimately, it's worth remembering that this all is generated by the information that's available online. So it's going to be a very broad, diverse set of tools, anywhere from the page views and downloads to social media to traditional citations and everywhere in between. I think that's an important thing to remember as we communicate going forward. So what's happening with altmetrics now, and I wrote this in kind of a panic because I injured myself on Sunday and then had to write these, so they're not as polished as they could be. There's really just the 3 points, the middle 2 are the same point. But we have some more standardization that's kind of coming down the pipeline, so I'll talk about the NISO working group, talk about some of the developments that have happened within altmetrics in terms of the shifting landscape, and some of the literature that's being published about altmetrics. So first, the NISO working groups. I happen to be a part of one of the working groups, so I'm more or less well-informed to talk about it. But NISO was given a large grant from the Sloan Foundation to start standardizing altmetrics. In phase 1, they held a series of in-person meetings to kind of gather what do you want us to do with regards to altmetrics, gathered all the information, and in stage 2, they set up 3 working groups. So they're listed at the bottom. I'm part of the definitions and case uses. So the reason why I talked about definitions in the beginning is because this is one of the things that NISO is really struggling with. And I can tell you, even within our working group, we've had like at least 20 to 30 minutes just talking about should we tackle definitions first or should we tackle case uses and how they're informed by the others, and then the other 2 working groups are also going to inform. So even among the experts, so-called, the people on these working groups, there's still a lot that's being, discussed, settled, finalized. So if nothing else, your takeaway from this should be, it's okay to be a little confused. Everyone is. So some of the developments that are happening in altmetrics, new tools are emerging, old tools are disappearing. So one of the newest ones is Elsevier's My Research Dashboard, which was announced last April as a way for scholars to start collecting some of their different metrics, including altmetrics like page views and downloads from certain tools, not a global thing, but into one dashboard for researchers. On the other side of things, there are some tools that were developed early on. ReaderMeter is one of those examples that's already extinct. So even in the span of less than 10 years, we see this rapid rise and fall, and it's so fun. Finances are shifting as corporations buy each other out. Plum Analytics was acquired in early 2014, and I suspect that this will not be the last time we see an independent company being bought out. And along that same line, Impact Story started as a freely available service for people to track their own individual scholarships through Altmetrics. And in July of 2014, they announced that they had to go to a fee-based system. So just as we are struggling to figure this all out, the tools themselves are also shifting and trying to figure out what makes sense from a financial perspective in terms of being able to support Altmetrics. So more is going to come before we start to settle. So all of this is kind of playing into each other. And finally, the literature itself, a lot of information science. Folks are looking at Altmetrics and trying to make sense of what does this all mean. So the chart that I have is from Altmetrics in the Wild by Jason Cream, Heather Purawar, and a third person, Bradley. Sorry, from I think 2011. That started to look at what are the correlations between these different types of metrics? What does this actually mean to us? There's kind of an interesting question in this of, do we want all of these metrics to correlate highly with each other or not? And I think my argument would be yes and no. So one of the highest correlations is between page views and downloads and later citations, right? Which in some ways is really great if you're someone who has just published a paper and have to show immediate impact of that paper. It hasn't had time to generate citations, but maybe I can use page views and downloads as a proxy, right, of future citation because there's a fairly high correlation there. On the flip side, if I look at something like social media, it has a fairly low correlation with citation, which at first glance you would say, oh no, it's not telling us anything useful. Well, it's just telling us something different, right? And this is all part of the message, which I'll come back to in the later section, that it is telling us something, it's just not telling us the same thing as Bibliometrics, right? But right now, it all gets put under that Altmetrics umbrella, so starting to tease out the different spectrum of impact indicators, I think is a really important step moving forward. And ultimately, this all gets at what is impact. And this is what everybody is struggling to kind of redefine. And how is the best, what is the best way to measure that? All right, so the more exciting part, perhaps, what do libraries currently do to support? So you'll notice this is, again, far less technical than what everyone else has been talking about, but just some ways to get the message out right now. So I'll talk about 4 specific areas: research guides, workshops and presentations, consultations, and some implementation of institutional level tools. And I'll just use one case study, but it is by far not the only example of institutions that are starting to use some of these tools. So this is kind of the most basic level that people tend to do, which is just put up information into a research guide for their researchers. I consider it a passive form of support because it requires a researcher to stumble across it, right? Or to search for it, or for you to send it out. But it just kind of sits there and exists. So this is from UNC Health Sciences. I happen to like it because I think it's a good mix of some exploratory information, explanatory, also walks people through the steps of how to sign up for some of these services, and also has links at the bottom to some more of the technical information and more advanced information for people who want to know more. Moving up a step, we have more active support in the form of workshops, which I personally think is a pretty interesting way to start to have that conversation with researchers. So one of the big issues that I've noticed is marketing. This is, I think, a cultural thing, and a lot of how you best support metrics often comes down to that cultural, right? Whether you're used to assessing information, what the level of engagement or interest is in metrics generally. It's going to change wildly from institution to institution. I happen to be on one where we're still talking about alternatives to impact factor, right? So we're at the very basic, like, hey, there's these other tools too. But some best practices based on what I've heard and what I've talked with other people who have produced some of these workshops. Reaching out to different audiences with different messages at the right time is a really great way. So my example is that I go to open meetings for people who are submitting tenure files or pre-tenure files. And I just distribute a little flyer. Say, hey, here's my research guide, here's my contact information. I'm here to help support you and talk with you about the best metrics for your file, right? So instead of just, hey, these are metrics, this is, hey, these are metrics you need right now. Another good strategy is to start packaging this information with other relevant topics. So up in the upper right-hand corner is one of my early workshops that worked best well, partly because I didn't avoid meaningless jargon. Bibliometrics doesn't necessarily mean that much to researchers, but some more impactful workshops have been things like maximizing research impact, or establishing yourself in scholarly circles so that you can maximize impact. It means that you can bring together some of these other topics that are relevant. So things like scholarly profiles, Google Scholar, ORCID, maximizing peer networks, like ResearchGate, academia.edu, getting them signed up and comfortable, and then integrating metrics and altmetrics into that workshop. So it's not just altmetrics, but it's putting it in the context of these larger issues. And finally, matching the right metrics to the right needs. I think a lot of people in this room are science. If I'm gauging correctly, I may be one of the only representatives of a social science heavy institution. Nope, oh good. Education, yes, that's right. Right, so Bibliometrics was founded in the sciences, right? There's a good reason. It works pretty well, right? And everything that we've talked about today with creating these technical reports is going to be a best fit for those disciplines that cite heavily, that write heavily. So introducing altmetrics may make less sense to them, but for some of the social sciences and humanities that don't always publish journal articles, that have alternate ways in which they're impacting the field, some of these start to make more sense. So just picking the right message for the right audience. There's always consultations, and I think a lot of us are already doing that. I just picked this two-page handout because I thought it was a really great way to show, this is Curtin University, but they kind of really detailed, here's what we can do for you. Here's what the library is here to support you with, and here's our contact information. So if you don't have something like this, to make sure that everyone is aware of your services, it can be a really great way to drum up business, so to speak. No, this is mostly bibliometrics. And finally, some institutes that are actually using altmetrics tools. So one of the first case studies was University of Pittsburgh, who implemented PlumX. This is an institutional level altmetrics tool, which is designed to look at altmetrics impact across the university. It's something that we can look at online, so you can go and look at their PlumX instance right now, which can start to get a sense for if I were to introduce altmetrics at my institution, what kind of metrics can I expect to get and how helpful would it be to my researchers? So I just pulled out some stats from their instance to get a sense. They have 51 researchers, but they've got over 70,000 artifacts. And of those, almost half of them are government publications. Which I thought was interesting. I thought it would be mostly articles. And when we're looking at those categories of impact, that's the part at the bottom. That really big blue line is usage. And that's coming from EBSCO data because PlumX is owned by EBSCO. So the vast amount of altmetrics that they're able to get is coming from EBSCO. And then the other four categories, citations, social media, captures, and mentions, much smaller pieces of pie. But you can drill down to dig into those levels to discover more about the impact for them. And if you want to read more or actually see a slideshow about their project, there's a link at the bottom of that page. Just to mention, because there is in the audience, altmetric for institutions is the other big institutional level altmetric tool that's available. And she was telling me this morning that they are working with several institutions, including Duke and Northwestern. Stony Brook. there we go.
World
Bank
Bank.
and others. So there are examples out there of institutions who have taken that leap into supporting altmetrics fully at the institutional level, but I suspect they're still trying to figure out what is the value added to this. And we look forward to hearing more about how that moves forward with those institutions. So the last part, what's next for altmetrics, and this is just me hypothesizing more than anything else, but it's not going to settle down anytime soon. There has been a lot of change. There will be a lot more change. I suspect there will be more tools coming. There'll be people buying each other out and possible merging of existing tools. There's going to be more discussion, more confusion, right, before this all gets settled out. However, groups like NISO are going to help standardize things to some degree, and maybe I'm putting all my eggs in NISO's basket, but I think once we get some better definitions, what are altmetrics? What are the reasons why we've used altmetrics for specific disciplines? Then we're going to have some real ways to move forward in meaningful ways with altmetrics. So, last thing, what can you do at your institution now? This is kind of a lot of what I've already said. Make sure to tailor what you're saying to the correct audience. And remember that altmetrics is just part of a larger conversation. So not just the peer networks and scholarly identity, but we're also talking about things like institutional repositories. Altmetric has a way to interface with things like DSpace to create altmetrics information for anything that's in an institutional repository, which is kind of a dual purpose of providing more incentives for researchers to put things in an institutional repository, and we have more information about the kind of attention that things in institutional repositories are getting, which is exciting. And of course, this is all informed by scholarly communication and open access. So there's a lot of ways to kind of fit this into larger conversation. One other thing that I would suggest is kind of growing a network of people who are interested and engaged in these topics as a way to kind of grassroots from the bottom up. So sometimes administrators could say, hey, I want you to do something with altmetrics. That's great. But more often we're going to have to demonstrate why altmetrics make sense for different researchers, different disciplines and groups. And that involves communicating with researchers and getting them on board. And ultimately, I think librarians are good at passing information, but we're also good, someone said earlier, serving as that neutral ground, right? So if we can get researchers to say these things for us, in some ways that makes a stronger case than us saying you should value this, right? So hosting panels, workshops, discussions. And finally, remember that we are not just people who are interested in altmetrics. We can actually use it for our own purposes as researchers, for our own files, and for collection development purposes. And hopefully I didn't go too long. I don't think it is. Okay, I have any questions? She asked Google Scholar citations, what they're doing in terms of altmetrics. This is going to be one of the fuzzy categories of is it a bibliometric, is it an altmetric? They are in the metrics game. If you go to Google Scholar, there's little metrics buttons along the top that will give you journal level metrics. The main metric they use is the H5 index, which is built on the H index but applied to journals instead of authors. Some of the main drawbacks is that it is only current. They don't go retrospective. It also is always going to be a current snapshot of journals, and it's only, it has the top 20 or the top 40 journals for any given discipline. But they have their own categories that are separate from Scopus's and separate from Web of Science. I personally have found it to be better, but not great, in the social sciences and especially humanities, and starting to break down those categories into something that makes sense. I can tell you for my personal researchers, I usually say if you can't find journal metrics in Web of Science or Scopus, you can see what Google Scholar has, but they're not as invested in it, I would say, as either Web of Science or Scopus. So it's going to be a little sloppier. But I wouldn't necessarily consider it altmetric, because it is still based on citation in journals.
And the still also know that that's a different H index. the other age.
There is pointing out that researchers don't often know that it's a different H-index than the author H-index, but same formulation. Any questions?
The National Academy launched institutional repository for publishing us, so if you go to NAT.review and go to a report page, there's a stats tab, and you can see how speaking from the library standpoint, we're sort of a nice section of our snapshot of metrics that we're trying to collect. So not only peer review, legislation, draft, now we've got the social extension. Now we're trying to play around with different ways to package that for the staff and experts in the business development.
Let me see if I can summarize. National Academy of Science now is integrating altmetrics into their website, and it's providing kind of a nice complement to existing metrics, and now they're figuring out what do we do with it. And I think that's where a lot of us are right now. What do we do with this? Other questions?
Online ask, oh, wait. Hold on. It scrolls up when someone asks another one. Do you have an idea of how libraries are delivering altmetrics data on a set of papers to researchers? Does that make sense?
I guess well, it's probably a simple explanation, but do you have an idea of how libraries are delivering a set of altmetrics on, say, a set of papers to those researchers? I haven't heard of specific people doing it. What I've heard of now is that institutional level and working with, say, departments or individual researchers that have a profile in something like Plumec in altmetrics for institutions. But my guess is that it's more driven by the researchers at this point than the librarians. So we're not going to just produce a whole bunch of altmetrics and shove them out to researchers who aren't interested. That's going to be a question from them first, and then we pull it all together.
Academic libraries are putting all that data in their repository. Altmetrics.com makes that available to academic libraries from the anecdotes we hear are that researchers are going after altmetrics. For example, if they're trying to get a visa for being this is a visa for like Harvard special. That's what they're using altmetrics for that.
You guys are killing me. How am I going to summarize this?
For tenure promotion and increasingly for making the broader impact case with NSF and NIH Bibliometrics.
Sarah of Altmetric wants to say that people are using it for specific instances are asking for altmetrics, including to support visa files for smart and special visas and some other specific uses, which sorry, I got stuck on the smart and special. It's a long way. Other questions? Is anything being done internationally in this area? I can tell you that a lot of the research that's being done in the literature that's being written is coming from Europe. The sigmetrics listserv that you referred to earlier is almost all Europeans that are fighting with each other. So much fun. Oh, yeah, and Snowballmetrics is a major initiative that's, it's kind of like a recipe book. Here's some different metrics that you can use to measure these different types of things that you may wish to apply at your institution, and that's also coming from European thinking. So I think in many ways, Europe is setting the stage for this more than us.
The question is the email address online for email address you have there, correct?
She's asking if my email address is correct. Yes, there's an 8-character limit to what you can put, so the T is blocked off on my email address. But if you put the T, it'll still get to me. Thank you for the question. Thank you.
All right, we're going to take another 10-minute break, and we'll reconvene at about 3 o'clock. Thanks. All right, so now we're going to hear from Brian Pate, who is not a librarian. He's very clear about that. But he is with the Department of Defense, and he's helping to coordinate a working group around technology forecasting and looking at some of the ways that they might be able to use some of these bibliometric data in order to do some of that work, and then also learn a little bit about what we're capable of doing and maybe how librarians might be able to help in that and assist in that kind of role. Again, just to kind of get us thinking about some of the other types of things we might be able to do as librarians in this bibliometric and scientometric space. So, Brian?
Thanks a lot, Chris. So not only am I not a librarian, but I am only involved in the TechWatch horizon scanning area on a part-time basis right now. My full-time position actually is as a program manager with a group, the Defense Threat Reduction Agency, that is under the Assistant Secretary of Defense for Nuclear, Chem, and Bio Matters. I'm serving part-time at this Office of Assistant Secretary of Defense for Research and Engineering. And under that, there's an office called the Office of Technical Intelligence that has three main focuses. The office director, by the way, is Christopher Gardner. Unfortunately, he wasn't able to be here today. But Chris and Nancy were kind enough to give us the opportunity to present some of our needs to you and to ask for your help, actually, in this effort. So the three areas of focus of Office of Technical Intelligence are, one is that they act as a liaison between the intelligence community and the Department of Defense, to the intelligence community, by, for instance, developing something called the Intelligence Needs Plan that informs, that stipulates kind of or asks for certain collection requirements that the DoD requests of the intelligence community in a more organized way than having each DoD agency go to the IC, although that also happens. And really, with the intelligence community, that interaction is for understanding current threats. And it feeds into our TechWatch activity, which is focused on current landscape within technologies and threats. And so the second area is TechWatch horizon scanning activity, and this is more future-leaning compared to our the intelligence community current assessments of threats and technology. And really the goal of the TechWatch horizon scanning activity is to identify emerging disruptive technologies. Okay? And then once these are identified, then the third arm of this Office of Technical Intelligence does deep dive assessments to provide context around these technologies and then ultimately make recommendations for the DoD for investments in these technologies. And so, again, going back to the TechWatch horizon scanning, here the goal is to identify emerging and disruptive technologies that will shape the future scientific technology landscape, to exploit novel TechWatch horizon scanning analytics to develop quantitatively based a tool that leverages both manual and automated approaches. So we don't want to rely solely on experts, as has been more the paradigm within the DoD historically. We also want to, but we also don't want to go purely. We don't believe that we can go purely to an automated approach. So we want to use the analytics to inform the decisions of these experts. We're moving within this TechWatch horizon scanning area from purely wanting to develop a tool to do this, and purely from identifying these disruptive technologies to organizing instead around what are the capabilities that these technologies will enable. And so, for instance, you could imagine that there's 4 steps that we've identified in developing a nuclear weapon. And so can we combine the data analytics with human intelligence as appropriate to assess foreign capabilities and put them against where the U.S. is and figure out what is the timeline that we should worry about that is relevant to a particular foreign capability. We really have learned, we need to identify the right people to be able to ask the right questions and use the right methods to get to the point of having roadmaps that are actually actionable and robust strategic plans. So the other thing I wanted to touch upon is that within the last month, we've, together with the intelligence community and the national security community more generally, stood up a community of practice within the area of tech watch and horizon scanning. So the DoD right now within the research and engineering enterprise is organized into communities of interest, things like the sensor community of interest, the countering weapons of mass destruction community of interest, one focused more around autonomy. But we view the technology watch and horizon scanning activity as something that spans all of these 21 communities. And so we're calling it a community of practice. And so we kicked it off about a month ago. The goal is to try to increase the coordination and rigor of technology watch and horizon scanning activity to achieve improved outcomes with constrained resources. And really, I think what was identified, one of the big things out of this community first meeting was that there's a need for process and cultural changes within the DoD and the national security community more generally, so that folks are more willing and able to access and use data-driven decision tools as the data influx is expanding exponentially. And some of this is to do with just stovepipes and particular sandboxes within the particular agencies or program offices that make up the Department of Defense and these national security agencies. But there's really a willingness to try to pursue things right now. So along these lines, so we came up, we have a planning committee that's met a few times since, a couple times actually, since this kickoff meeting, and we're planning to bring together the full body again, which was about 100 folks or so from across the government back September 15th sort of time frame. And the action items right now are really revolve around developing clearly articulated and prioritized needs within 3 areas, within the research and engineering enterprise, within what we refer to more as the operational and strategic kind of areas, and that includes countering weapons of mass destruction, and then within the intelligence community and the analytics sector that have their own particular needs. And so we're developing those needs. At the same time, we're trying to compile a list of tools and data sources, where these reside, who's currently paying for them, recommendations for where they should reside and who should pay for them in the future, how they could be integrated together to inform this activity. And I think that's where we could ask for your help, actually. I've seen a few of the presentations listing various tools and capabilities that are out there, data sources. So we'd really like to get a good understanding of what capabilities are out there, because there is money within the DoD and within the IC to support these efforts actually right now. And then in addition to that, we're interested in establishing sort of standards and keeping score and maintaining metrics. I know there are various efforts to do this already, but for these Tech Watch horizon scanning activities, when we make a prediction or change a policy or an investment strategy based on a particular Tech Watch horizon scanning effort, quantifying whether that was a good change and whether what we predicted is actually coming to fruition or not. Sometimes that is complicated by the fact that we're injecting money into these areas, and so sometimes these processes can become self-fulfilling. And then the other thing is what these are feeding into, these clearly articulated prioritized needs together with the tools and the data sources that we hope to leverage communities like this to obtain are, there's two assessments that are being put together right now, one within the DoD, ASDRNE, and then one within the intelligence community, with the ODNI and the National Intelligence Council is putting together an assessment of, you know, what are the practices right now within the intelligence community and within the DoD, and then and then we want to provide recommendations for how those should change going forward. And so again, your input to that would be very much appreciated, this community's input, and I guess I'll rely on Nancy and Chris to try to help organize that as we move forward. That's all I have.
I think it's wonderful that you do it. I think the fact that often sets up defense at high level for defense and intelligence, asking the librarian involved. So you might want our community to tell you about the two separate
Absolutely.
That narrative information. And there was some discussion about tools that your community might be purchasing with data centers or prototyping, and that perhaps at some point you might want us to do that.
Yes, and we do have a website that organizes these tools and capabilities that we're prototyping, and I can share that with you, maybe distribute back in the post-meeting report to the community.
So I just wanted to chime in that I think that you sort of gathering people in the community to share best practices and talk about what it is that you're doing is exactly the reason why Kristi is pulling us all together today. And we certainly appreciate your willingness to work with the librarians who believe in a lot of people. Thank you very much.
Thank you.
I had a question. Is the community assessment, on, was it Pate or anything like that? Or is there like a way that somebody who's involved in the DoD work can actually join?
Yes, and so again, let me go back and get the exact link for you,
Okay.
and then we can share that. I don't have it in, but we do have a website. I'm not sure if it's on text-based yet, but it's related to the area. Okay.
All right, so we're going to move into the discussion phase of this today. For those of you, quick announcement for those of you on the webinar, unfortunately we don't have capabilities to, we don't have microphones essentially, so we can't broadcast this over the webinar. So what we're going to have to do is we're going to have to sign off of the webinar and have the discussion just be here in the room. However, we are going to take some very detailed notes of what all we discussed here today. So we'll be also making those notes available so that you can at least have a record of what we talked about. So again, we apologize that the webinar is not going to work for this, but just due to technical limitations, it's just not going to work. So we will follow up with you, and thank you all very much for attending today.
Thank you.
Okay, so I want to kind of make this a little bit more informal than it has been. So just a couple of general questions. So does anybody have